when creating JavaScript applications, there are some times when you want to have, for example, some kind of a number. And that number doesn't really represent something. That maybe is, for example, for managing the state of a function that you are actually working on. And for example, you are saying, okay, if the number is 1, I want that action to start. And if the number is 0, I want it to be completed. Now, these kind of magic numbers, they are really a pain when you're working in JavaScript, but they're extremely easy to create when it comes to TypeScript. And the reason for that is that we could come up with these kind of magic numbers using enums or enumerations in TypeScript, and we could create some kind of an enumeration that doesn't have any runtime element to it, which is really exciting. And that is why I decided to dedicate a complete section to the topic of enumerations or enums or enums, whatever you want to call them. And specifically in this section, we're going to talk about basics of the enums, examples. We're going to talk about constant and computed enums, string enums, and finally, we're going to talk about how to check for every single condition or exhaustivity checking for enums. Let's get started. Enums provide us with a way to create named numeric constants that we can use in our applications. We have already talked a little bit about enums, but since enums are quite a powerful tool of TypeScript, I wanted to dedicate a complete section to it and just to further explore the enums and how they compile into vanilla JavaScript. I'm going to get started with creating our enum first. So to create an enum, first we need to type the keyword enum and then the name of the group of constants. And in this case, I'm just going to name it crops. And then we need to specify the constants itself. So I'm going to have barley, and then I'm going to have corn, and after that, I'm going to have wheat. And as soon as I save that, we are going to see the compiled JavaScript, and I'm going to go over that as well. Since I did not cover that in depth, it was just like an introduction to enums, and this section is like more dedicated to enums and how that work. So as soon as I save that and we take a look at the JavaScript code, the first thing that you might notice is that we have actually ended up with an immediately invoked function expression. We create a function right here, and we immediately invoke that function right here. Now, I'm going to go over the syntax in a lot of detail in this lecture, so I'm going to zoom in so you can really see what is actually happening here. So what TypeScript has done for us is that it has grabbed our enum, and it has converted it into a JavaScript runtime object. In here on line number 2, we can see that the object is being initialized, but no values has been provided. And then we have a function that selects that object. So the name of enum that we provide, that is going to be the name of the object that we are going to end up with. Now, since this function requires an object as a parameter, we need to pass in an object. That is why when we invoke the function right here, we are passing crops or an empty object. Since it can only accept an object. So now we know that this is actually an object. Now, within the function itself, our named constants are populating the object, the JavaScript runtime object. And we are going to end up with several different properties, and I'm going to explain to you how we actually end up with those. I'm not going to log it to the console. I'm just going to explain first, and then we are going to take a look at it in the console. Now, the first things that you're going to see is that we have this object crops in which we have a key of barley, and then we have another key of corn, and then we have another key of wheat that have specific numeric values. The first one has a value of 0, the second one has a value of 1, and the third one has a value of 2. So we already have 3 different properties. These are going to be the three members of the object. And the object actually has 6 members. And you might be asking, okay, where are the other 3 coming from? So we have this barley that we specified to 0, and then corn to 1, and then wheat to 2. And then we have the entire returned expression from this within this square brackets, and we are selecting this entire thing and we are assigning it to barley, and then for the corn we are assigning it to corn, and then we are assigning it to wheat. So the returned value from this highlighted expression is going to be 0. For the second one is going to be 1, and for the third one is going to be 2. So we have 3 keys with the names of barley, corn, and wheat, and we have 3 keys with the values of 0, 1, and 2. And I could just show that to you by just logging it to the console. So console log crops, and as soon as I save that, we can see we have an object that actually has 6 members. So 3 of the keys are 0, 1, 2, and that is the returned expression, the returned value from this expression, which is 0, and we assign that value of barley, as you can see right here, and then a value of corn, and then a value of wheat. And this barley, which is a key, is basically this one, that we have selected this barley and we have assigned it a value of 0. So barley has become the key and 0 has become the value. And now you know exactly how TypeScript's enums, they are being converted into a runtime JavaScript object. Now, a runtime JavaScript object has a lot of benefits. Now, as far as we are within this TypeScript code, we can see that it's not that obvious that this is, excuse me, this in fact is an object, but we can use all of the object methods that you have studied in JavaScript. You can use all of them on this enum, because the enum in the runtime is going to be a JavaScript object. You have access to all of them, and there is not going to be any runtime error. So if I do a dot, using the dot notation, we can access the members of an object. We know that from JavaScript. And we have that availability in TypeScript as well. So as soon as I do barley and I select that and I save it, we can see we got 0. So we have all the good things, all the perks of having working with objects, and we have access to all of them when we are creating enums. And we could also, since enums, they start with a number 0, we could initialize the constants as well. For that, I'm going to just comment this one out, and I'm going to paste it down below. So you can have this as a reference. And I'm going to comment out the log as well. Now, if you don't want the number to start from 0, you can always initialize it to starting from 1. And as soon as we do that in the output JavaScript, we can see that it starts from 1, and then 2, and then 3. And if I take a look at the object in the log, it's going to reflect the changes. 1, 2, 3, and then 1, 2, 3 right there. We could also fundamentally change the basis of constants. Now these constants, now the entire point, all the point behind these enums, or the enums idea, is to provide us with a systematic way of keeping track of state of our applications. Now, what I mean about in talking about state is that sometimes what you require in your applications is that you require like certain numbers to keep track of. And those numbers, instead of being like magical numbers, you could actually name those numbers. So you really know what that number means. That number could mean the number of times a post has been clicked, or the number of comments that have been provided to a post. So instead of having like 1 or 2 or 3, you do have that 1, 2, 3, or whatever number it is that you want, but you have a name assigned to that constant. So if you come back to your application after 3 months or 6 months, you know what that number actually means, what that constant means. Because the constant now has an identifier This is something that you can't do in JavaScript, but you can do that systematically in TypeScript, and you can actually preserve type safety of TypeScript as well. Now, this is the idea behind enums, and that's why I actually dedicated a different section to it. Now, we could fundamentally, again, change how an enum operates. Enums, they start from 0, 1, 2. I showed you how you can do that with like 1, 2, 3. But you can also use an enum to use, if you want to have like an expression that produces a constant value, and that expression should not be too complicated, you could use that as a value for your enum as well. And what do I mean by that? For example, I'm going to comment that one out again, and I'm going to come down here. You have some sort of an expression, and you want to start from that expression, and then you want to move forward. For example, you have some sort of a string, like you have a string of barley itself, and you want to find out what the length of this string is, and then you want to assign that length to the constant, which is barley. You can do that as well. And as soon as I do that and I save it, nothing is going to be transpiled into JavaScript because we have an error. And why is that? Because what it says is that enums must be, enum member must have initializer. Now, since we have fundamentally changed how the incremental process of enums work, we need to initialize the next constant. So TypeScript can take that initialization and apply it in an incremental manner to next constants. Now, TypeScript doesn't know what this is, this barley.length. TypeScript's internal compiler doesn't really understand this in the context of itself, in the context of TypeScript. So what TypeScript will do is it's going to transfer this into the JavaScript. It's as it is, exactly as it is, because TypeScript compiler cannot understand this. Now, let's come back to the error itself. Now, we need to initialize one of the constants in a sense that is easier for TypeScript to understand. For example, I'm going to say corn is 2, and now the error is gone, because TypeScript knows what 2 is, but it is difficult to know what barley.length is as a constant. So as soon as I save that, an amazing thing has happened. We can see that for corn, we have 2, and for wheat, we have 3, and in an incremental manner. But that is not the amazing thing. The amazing thing is that since TypeScript cannot evaluate barley.length, it has used that barley.length and it has transferred it to the runtime JavaScript object. And that is why you can see there is not a number here. It just says barley.length. And now it is the JavaScript's job to understand, okay, how many letters are within this string, and then calculating the length of that. And if we take a look at our object in the console, we can see that it says it is 6. So we have 2 for corn, 3 for wheat, and then we have 6, which is the number of letters, which is that length. And these are the limitations that you need to think about when you're working with enums. That enums, they have to be constants. If you want it to be like some sort of an expression, like barley.length is a very rudimentary, yet it is an expression. It's very rudimentary, but it is an expression nonetheless. Then you need to understand that TypeScript is not going to be able, the compiler is not going to be able to decipher that. So that will be transferred to JavaScript, and then JavaScript is more powerful. JavaScript is going to know, okay, what barley.length actually means. That is it for this lecture. See you in the next one. Hi everyone. In this lecture, I would like to give you another example of an enum and how we might actually use an enum within a function. Let's say we have a repository and we want to commit that to GitHub. Now, the issue is that we don't know whether or not our repository has been committed to GitHub. So what we want to do is we want to keep track of the state of this particular application using an enum. So I would create an enum, and I'm just going to keep it very simple, all right? I'm going to create an enum, and I'm going to say get repo, or repo, not sure which way is correct, and I'm going to create two constants. And I'm going to create one constant that is going to be not committed. I think this is not committed. This is spelled correctly. I hope so. And then I'm going to have another one that is going to be committed. Now, as soon as I save this, and we will be able to see the transpiled JavaScript, and we know that the value that TypeScript is going to provide or assign to not committed is going to be 0 and committed 1. So we have 0 and we have 1. If the repo is committed, it is 1. If it is not, then it is 0. So everything is making sense so far. And we have already talked about this function that we have within JavaScript and why it works the way it does. And let's create our function. So I'm going to say is repo committed. And what I'm gonna do is I'm gonna provide it with a parameter, and that parameter is gonna have the type of the enum. I'm gonna type annotate it to our enum. So get repo, and what I want this function to give me at the end is just a Boolean value. I want to know whether the repo is committed or not. So the returned type from the function is going to be of Boolean. Cool so far, right? So what I want is the function to return the following. Now, I want to check whether or not the repo is empty or it is full as well. So I'm going to say if repo is equal to null, I want to return this, or I want to return whichever is true, I want to return that. Or if repo is equal to get repo. Now, which value was dedicated to committed? It is the committed key itself. So I'm going to say dot not committed. Now, the reason that I'm saying not committed is that we are going to check if the repo is null or if the repo is not committed. So is repo committed? If this side is true, then we are going to end up with a false. I'm going to check for committed as well in just a sec. So first off, we are going to check the function in this context. Now, the cool thing with these kind of enums is as following. It's not the idea behind this example, but we are just trying to understand enums a little bit more. So I'm going to say get commit, and I'm going to grab our function is repo committed. And as soon as I open that, we need to provide it with one of these two values. So we need to provide it with either not committed or with committed. Now, if I do committed like this, we can see that we don't get any intelligence. Why? Because committed on its own doesn't exist. It is an object's member. So to be able to access the object's member, we need to reference the object itself. So it is get repo dot committed. Cool, let me remove that. And as soon as I save it, we are going to see the result in the console as well. Log get commit, and I'm going to save that. We get false. Why do we get false? Because this return function, this is only going to return for us if either the repo is null, it means it's empty, or the repo is not committed. Now, if I just change this with not, and now we are going to get true. Why? Because this side of the operation, this side of this logical operator has returned the value of true. Therefore, this function returns true. And at the end, we know that is repo committed? We know that it has not been committed because it says not committed. And I think it would have been better if I just remove this get repo.committed just to change it with .committed so we know that the repo is actually committed. So if I just say repo is not committed, it is going to say false. But if I say repo is committed, then we are going to get true. You could go either way about this, but the cool thing is that instead of having any kind of value in here, I forgot to provide another assignment operator. Instead of having any kind of like magical number, Like let's say we could have, instead of not committed and committed, we could have 0 or 1. Then that would have been very difficult for us and for the people who are actually taking a look at our code, for anyone who takes a look at your code, to understand what that 0 actually represents. So if I were to remove this entire thing, and if I replace it with 0, and if I remove this entire thing and replace it with 0, it is very difficult for you and for any other person or developer to understand what the 0 actually refers to. As soon as I change this to 0, it is very difficult. But as soon as they see it, like, okay, get repo that committed, they know, okay, that the repo, this side is going to return true if the repo is committed. So these kind of like 0 or 1 or 2 or whatever kind of numbers that we have, and we provide them with identifiers, it means that we are documenting our code. So from a documentation standpoint, it is also beneficial for us to use enums. We have already seen how the following enum is going to work. If I just do Control Save, and we can see what it is going to print and how it's going to work. Now in this lecture, what I would like to talk about is constant and computed enums. Now, there might be a situation in which you do not need a runtime JavaScript object. And by a runtime JavaScript object, I mean you don't need this function to create members, to create an object and populate it with members. In such scenarios, we can do something that is called inlining an enum. And by inlining an enum, what we actually mean is that there is not going to be any JavaScript runtime object produced from our enum within our JavaScript code. So if I have not committed and committed that have values of 0 and 1, in the JavaScript realm, we're just going to have not committed and committed with the values of 0 and 1. We are not going to have any traces of an enum present within our JavaScript code. And we are also not going to have any traces of an object. So we are going to lose that capability of working with objects when we create enums. So the way that we can create a const enum would be to just go ahead and provide the const keyword at the start of our enum. And as soon as I do that, we can see there is nothing in here. And now repo, instead of saying get repo.committed, it just says 1. And I did show you this example. Now, as until you are within the TypeScript realm, it makes sense. Everything is working okay. But as soon as you transition over, or basically move over to the JavaScript, you can see that we have a number. We have like some sort of a magical number that we don't know what it actually represents. What is repo? If repo equals to 1, what is 1? What does 1 represent? Now we have something in our application that we don't quite understand. And that is the issue that enums are trying to solve. Now, there are particular use cases for this kind of const enums. And one of the use cases is that you don't want to have any kind of runtime JavaScript object. You don't want to have that. And you don't want to have all of that code that goes into it. You just want to have this number, magical number in your TypeScript, and you want to inline the value of that number, that constant, by just 1 or 0 or whatever. So instead of saying not committed or committed, when we say 1 in JavaScript, we're basically inlining the value of that constant. Now, I've already talked about that. There is no representation of any kind of object within our JavaScript. Now, that is one of the aspects of constant enums that you need to keep in mind. Another limitation of constant enums is that you cannot provide values that are expressions. Now, we have already seen that, I believe it was the first lecture of this section, that if you want it, you could say like initial commit, initial commit dot length, and you could do that. Now TypeScript is not able to handle that within the TypeScript code, within the TypeScript file, so it's going to transfer it or to transpile it or compile it to JavaScript, and then that is the JavaScript's problem to decipher what this actually means. But as soon as you do that with a constant enum, we get an error. And the meaning behind this error basically is that the values of enum constants can only be constants in the case of constant enums. They can only be constants. You can't provide expressions. They can be expressions. This is because constant enums are limited in scope. So we can only pass in values that are constant. And by constant, what I mean is the kind of value that TypeScript can resolve without the interference of any runtime element. So without just jumping into the runtime, which is JavaScript, TypeScript can understand that and can solve that. Now, this expression, this is not actually a constant expression. This is something called in TypeScript a computed expression. And what this actually creates for us is a computed enum. Computed enums cannot work within constant enums. So what we have to do is, the first remedy for this code would be to remove the const keyword itself. So if I remove this, we get a different kind of error that we need an initializer. We could say it is like number 10. We have already seen an example of this and how this actually works. But if you want to still stay within the realm of the constant enum and have an expression, well, you can't. You can technically have expressions, but they have to be extremely primitive. And what do I mean by that? So you can't have this initial commit that length. This is not possible. Why? Again, because TypeScript cannot resolve this without the interference of any kind of runtime element or any runtime interference. TypeScript can't do it. The TypeScript compiler can't. That's why it's throwing an error. Now, what TypeScript compiler can do for you is, for example, I'm not going to provide it on the first one. I'm going to provide it on the second one. Doesn't really matter, but I'm just going to do it on the second one. It can handle or resolve expressions that are very simple, like 5 plus 2. This TypeScript can do for you. And now you can see the value is 7. Now there is no error because it's simple enough that the TypeScript compiler can handle or can resolve without having to resolve to the ultimate runtime expertise of JavaScript. Since JavaScript is able to handle all of that, but TypeScript is a little bit limited in scope because of trying to keep all of the type safety. So you need to keep in mind with constant enums, you can do expressions limited in scope, but you don't get that object that your application is not going to be that bloated. But if you want to have expressions, if you want to have runtime objects, then constant enums are not the way to go. We have already seen several different types of enums, like normal enums, constant enums, computed enums. In this lecture, I would like to talk about string enums. But before starting this lecture, there is something that I actually forgot to talk about in our previous lecture, and that is what if you want to have constant enums that also can produce a runtime JavaScript object. Well, you do have that ability. You can have that ability, but you need to add it to your TypeScript configuration file. So jumping into the TypeScript configuration file, we can see towards the end, the way that you are going to end up having that final runtime object is by providing a setting, and that is preserve const enums, and I'm going to set it to true. And as soon as I do that and I save this file, I didn't have to even save it because it is currently in the watch mode. Our terminal is in the watch mode, so it is watching for all the changes. Even though we have a constant enum, we have all the perks and all the good benefits of having an object. while maintaining our limited scope of our enums. Now, constant enums not being able to evaluate complex expressions is actually a good thing, because at the end of the day, the idea behind an enum is to provide a constant value. And if you want to overcomplicate it with expressions, then you should probably move away from that and just use regular objects. Cool. So that part is done. Now we are going to dive into this lecture. So I'm going to close that. And in this one, we're going to talk about string enums. I'm just going to take a look at this. That's it. That is done. So let's talk about string enums. This lecture is going to be very, very simple. We have already talked about how enums constants are numeric in type, but they could be string in type as well. They could be like string type. So for that, what we are going to do is, let's say we create an enum and we are going to call it employee. This employee is going to have a name, and I'm going to initialize it to John Smith. And this John Smith also has a job that is initialized to front-end developer. And this is the job, developer. Let me take a look at that. Okay, let's provide a comma there, and there we go. And as soon as I do that, and if I take a look at that, since we have removed the numeric nature of the enum, we no longer see that. And as soon as I console log it to the console, we are just going to have two different members, and that's it. We are not going to have four, because there is no numeric values. We have a key of name that is going to be that is going to have a value of John, and then we are going to have a key of job that is going to have a value of front-end developer. So in here, if I do employee and save that, we are just going to see that job and name. It's like alphabetic, chronologically ordered. That's why J comes before N, and that's why it shows it like that. We could also use this enum within a function if we wanted to. So I'm going to create a function. Let me bring this down so we have a little bit more real estate. Function, and let's say we want to get the employee info. This is our function, and I'm going to say employee. I'm going to pass in a parameter of employee, and I'm going to type annotated to the employee enum. Now, what do I want this to return? Now, so far, if I just hover on it, it is going to return void. It doesn't have any return type, but I want to return the actual employee itself from this. So the return type is going to be employee as well. Save that. So I'm going to say return employee. And as soon as I save that, we can, let me just invoke the function, log get employee info. Let's log it. And what is it going to require? It's going to require us to provide a name and provide a job. So I'm going to say employee dot name, and you can see the IntelliSense. As soon as I do dot, we got the name, and if I save that, we get John Smith. And if I take a look at the job, it is going to be front-end developer. There we go. So I'm going to comment. I'm going to get rid of this console log, so we only have those two console logs. So we have been able to use this name and this job constants that have string values, and we have successfully used that within our function, have changed that perhaps in some way or another, and we can also have access to those as well within our function. That's it for this lecture. See you in the next one. Exhaustiveness checking generally means that all the corner cases of a program have been checked, and there will be no surprises when the app is shipped to production. In the context of TypeScript enums, an exhaustivity check checks all the members of an enum, all the constants within an enum at compile time. So no edge case would be converted into a bug in runtime. For this example, I'm going to keep things extremely simple. Let's say I have an enum that is going to keep track of how many courses that I have. And the job of enum is to make sure that as soon as I put out a course, the course has a specific price. And that's what I want to do. That is the main of our application. Now, if you think you can do that, go ahead, pause the video. But if you have doubts, then just keep watching. And I'm going to show you how you can do that. Let's first create our enum, and that enum is going to be called courses. And within this, first off, let's say I just have 2 courses. I have, even though I have more than those, but this is just an example. Let's say I have TypeScript course and a JavaScript course. And as soon as I do that, we can see all the magic that is happening within our JavaScript, and we have already talked about that. Now, the cool thing is not that. The cool thing is what is about to come. I'm going to create a function that is going to basically decide the price of the course. And this function is going to say, this is going to be set. The name of the function is going to be set course price, very self-explanatory. And it's going to accept every individual course from this type of this enum of courses. Now, I could go about this using if statements, or I could go about this using switch statements. I'm going to go about this using switch statements, since every case that we want to handle is going to be a different course. So if I have a course named TypeScript, I want to give it a different price. If I have a course named JavaScript, I want to give it a different price. So we need to employ conditionals in the scope of this application. So I'm going to say switch. Now, the condition against which we are going to check our course prices is going to be the actual course. Now, I want to check whether I have a TypeScript course or a JavaScript course. So I'm going to say case. If the course is TypeScript, how can I actually understand that and keep type safety at the same time? I could say courses, and as soon as I do the dot, we can access the TypeScript from there. So if our course is TypeScript, what do I want the price to be? So I want this case to return a value of $29.99. So if the course is TypeScript, the value is going to be $29.99. And what about JavaScript? I'm going to say courses.js. If the course is JavaScript, then I want the value to be $25.99. Now, this is working correctly. Everything is working as we want, and it's fine. So far, everything is like perfect, and everything has been priced. But the thing is that if I go ahead and if I try to add another course, let's say Python, I'm not going to have any way of knowing whether the Python course has been priced or not. I don't know that, because the TypeScript compiler doesn't tell me that you have added a course Python, but that Python course doesn't have a price. Now, the aim of this application is to basically to know whether or not a course of mine has a price. Now, a common resolution to this issue would be adding a default statement, and having this default statement throw an error. So I could say throw new error, and what do I want the text of the error be? I'm gonna say course. Let's use backticks. That's easier. So course, this one doesn't have a price, has not been priced. And as soon as I save that, we could have this function as well. Now, the way that I'm going to run this is, let's go ahead and let's say log and set course price. I could perhaps zoom out just a little bit so we are not moving that much back and forth. And I could either pass in like any course that I want. So let's say I pass in courses dot, and as soon as I do that, let's pass in TypeScript. And if I save that, we can see we got an error. And what does that error says? It says course 2 has not been priced. So this is coming from here. This is the text of our error. And the issue with this kind of approach is, I'm going to give you like a couple of seconds to think about it. What is the problem with this kind of approach? The problem with this approach is that now our error has been able to penetrate our JavaScript code. And when it penetrates the JavaScript code, it is bound to penetrate the browser. And as a result, the user is going to suffer. So the user is not going to know, okay, what this is, what is set price. That is something that is visible to us as developers. So instead of showing this error in the console of my browser, I need to come up with a way to actually resolve this and not have this even penetrate my JavaScript code, let alone be within the browser itself. So this is not something that I want. And this is where something comes into the picture. It's something that we have already talked about way back, and that is the never type. The never type is actually a primitive type that is going to whose value is never going to reach. So if I use the never type in a way to use it like in a function or something, I should be able to come up with a way to tell me, for TypeScript compiler to tell me that this course doesn't have a price, and not have the browser scream at me with an uncaught error, which is not something that I want. So instead of the browser screaming at me, I could have the compiler scream at me at the time of writing my code so I can fix it before I ship it to production. So that is the main idea. I'm going to comment out this line and I'm going to keep it right here. And you can see now the function says undefined because the Python doesn't have a value. Now, let's create another function, and that function is going to be able to handle this edge case for us. I'm going to create a function. This is our function, and I'm going to call it course warning. Cool. And this function is going to accept a course, and the type of the function, the parameter type, is going to be never. Now, a little bit about never, even though we have already talked about it, just a refresher. The never type is assignable to any type that we want. However, no other type can be assigned to never except never itself. This means that you can use narrowing and rely on never to do an exhaustiveness checking for us. So what this never does is whenever we provide it, it is going to take a look at all the members of this enum, and it is going to pinpoint whichever member doesn't have a price. So it is going to check all of them one by one. In other words, it's going to do an exhaustiveness checking on our enum before our enum has been compiled into JavaScript. It is going to do an exhaustiveness checking on it. And that's exactly what we want. So this function is going to return never as well. Now, what do I want to do here? Basically, I want to throw an error. So I'm going to pass that here, and I'm going to say throw new error, course has not been set a price. Now, how can I use this within this function right here? So instead of saying this, I'm going to keep it, you know what? I'm going to keep it as a reference for you. I'm going to invoke the function right here. I'm going to say course warning, and I'm going to pass in basically the course. So whichever course doesn't have a price, it should show me the warning. And as soon as I save that, you can see that there is a warning. Why? Let's hover on it. Now there is nothing being compiled to JavaScript because there is an error in our TypeScript. And as soon as I hover on that, it says argument of type courses is not assignable to parameter of type never. And what this basically says that there is something in here that doesn't comply with our code. And we need to go ahead and we need to either remove this Python from here, or we should provide it with a price. So as soon as I remove the Python from there, and as soon as I save it, we got another error. And you can see there is like these kind of different errors. And as soon as I remove that, you can see that this function is working correctly. And now it says property Python does not exist on type of courses. Now I'm going to come back. I'm going to rewind this. I'm going to add Python because I just felt that this wasn't a good explanation on my part to give you like, okay, now this is checking for exhaustivity. It does check for exhaustivity, but keep in mind, where are we invoking the function? The function course warning is being invoked in the default statement. When are we going to refer to the default? When are we going to do that? When neither the first case nor the second case have been resolved. So when the course doesn't exist in here or in here, then we jump into the default. And as soon as I jump into the default, you should know as a developer of this application that there is a course that doesn't have a price. That's why it throws an error, because we are invoking this function. Now, as soon as as far as all the courses they have prices, it's not going to invoke this function. Why? Because we're not going to jump into the default statement, because one of these cases is going to hold true, and we don't have to come to the default. Because if we come to the default, it is going to throw this warning, and this warning is just an exhaustivity check for us, and it is going to immediately, even though the message itself says type course is not assignable to parameter never, it immediately tells you that when you come back to the function that says course warning, you know that the function says course has not been priced, and you immediately know that you have added a course for which there is no price. And if you remove that course, we basically jump out of this default statement. We go back to either TypeScript or JavaScript. That's why the error goes away. As soon as I remove that, the error from here goes away, because now we are not within the default. We just have TypeScript and JavaScript. And as soon as we remove that, and when we are not in the default, this is not being invoked. And when this is not being invoked, it means that this function doesn't do anything. It's like we have this function to not do anything as long as we provide all the courses. It's not going to do anything. But it is here, it is like a little bit of overhead for us to maintain this function, but we do it just to make sure that we have a type-safe code. And now if I remove that, just to escape from the never type, we end up with another one that says another error. This is type Python this property doesn't exist on courses. And as soon as I remove that, there is nothing wrong with our code. And if I save that, you can see that the price of TypeScript is $29.99. I can invoke that again, and I can say the price of JavaScript is $25.99. That's it for this lecture. See you in the next one.
Hi and welcome to part 8 of Let's Get You Coding Challenges. I hope you have had fun and you've learned a lot from our enum section. And in this section, we're going to put all of that into practice. Hi and welcome to the first challenges solution for enums. The challenge statement for this challenge reads that we need to create a group of 5 constants for 5 products. And those products could be of products of your choice, whatever product you want to create. And then we need to initialize the enum with 1. Let's go ahead and let's create that enum. Since these are products, I'm just going to call them products. I'm going to create an enum. And the name of the enum is going to be products. And within these products, we're going to end up with 5. I'm going to add 5 products. And the name of the products, they could be whatever you want. So I'm going to say TS Bootcamp. And I'm going to initialize this with 1. And as soon as I initialize this with 1, the rest of the products, they're going to have subsequent incremental numbers like 2, 3, 4, and 5. So the next one is going to be JS Bootcamp. JS Bootcamp. And I'm just going to provide a comma. After that, we're going to have Python. Python Bootcamp. From there, we're going to have CSS layouts. It is layouts masterclass. I'm just going to write CSS layouts, and this is going to be Flexbox grid course. Grid, and I'm not going to do the course. Just provide a comma, and I think that is it. So that is it for this challenge. See you in the next one. Hi and welcome to the second challenge solution for enums. The challenge statement reads that we need to perform an exhaustiveness checking for the previous enum and return their prices. We need to return the course prices. Now, I still have my enum right here, and in here we're going to do an exhaustiveness checking. I'm going to create a function. I'm going to try to write it small since there is going to be a lot of code. Function, I'm going to call it set course price. I'm not sure if you can read it, but I think you can. So I'm just going to pop to the back of the camera and just check if you can read that. If that is too small. It is too small, but it is readable. It's a little bit smaller than usual, but I'm sure you can read that. Set course price. The argument is going to be, the parameter is going to be the course, and I'm going to type annotate it to our products. Products. And what this function is going to do is it's going to check for every individual case. We have 5 products, so I'm going to say switch. What are we going to check against? Where is the T? Here is the T. We're going to check against the course, and that course is going to have certain criteria, certain properties. If it has the TS Bootcamp, then we're going to return one price. If it is JS, we're going to return another price. So switch course, then we're going to jump into our cases. Case, the products, if the product is TS Bootcamp, I'm just going to write it TS for short, not to waste too much time. Then what are we going to do? We are going to return 1099. And then we're going to check for another case. So in this manner, first we're going to check for TypeScript, then we're going to check for JavaScript, and so on and so forth. So switch case product is TypeScript, return this. If case product is JS for short, then we're going to return 9.99. Doesn't really matter what the price is. Now these prices, I think I've written them as strings in my solution, but they could very well be numbers as well. They could be numbers as well. But just to make sure that I'm in line with my solution, I'm going to provide them as strings. All right, is it readable? I'm not sure if that is readable. And I'm missing an S here as well. Cool. Perhaps I could have written them in 2 different colors, but the issue is with this green one, it is really wide and it's like really thick, this line. And it's not like paint, and I can decrease the thickness. So I can write it with that, and the red one is for type annotations. That's why I'm just using blue one. The solution is in front of you. I'm just going over the solution. And then we're going to have another case. First, basically what exhaustive checking means is we need to check for every single case. That's what we need to exhaust our options. How many options do we have? 5. If you want to exhaust your options, you need to think about all 5 of them. That's what basically it means. Case product. Then we have Python. We're going to return some price. For example, 11 0.99. If it is this one, CSS products, I'm going to say CSS layout, then we're going to return some other price. Return perhaps $12.99. And finally, we have case products, Flexbox. I'm just going to write Flexbox. Then we're going to return some other price. Now, there might be a condition where we're not sure if we have done an exhaustiveness checking, and that is why we need to provide like a default statement that is like the else clause of if statements. Default. And in default, what we're going to do is we're going to call a function that is going to be course warning. Course. That is going to warn us if we have not performed our exhaustiveness checking correctly. And here is the function. And I think everything is okay. Everything is working fine. But we need to pass in a reference for our course. So I'm going to say course. Cool. And I think we're done with that. Let's go ahead and let's create this function. The name of this function is going to be course warning. And I can't write this line. There is not going to be enough space. So like this is going to be better. So function. What is the course name? Course warning. What is the function name? Course warning. You could come up with a better name. We need to pass in a course object. Course that is going to be type annotated to never, because we never want to end up with this one in the case that we have not checked for any of these. And the function's return type is going to be never as well. So we never end up with this scenario, but we want to handle that in case we do. And in here, we're going to say throw new error, throw new. Is the N capital? No, it is lowercase. I always get this wrong. Throw new error. And we could provide like some message in here that is going to be shown on the screen. Just to make sure that we have everything. We have actually accommodated all of our options. And if there is an option that has not been added here, this function, since it is being invoked in the default statement, it is going to get invoked. For example, if I add a Tailwind course. Tailwind course has not been checked in these 5 scenarios. So it's going to come into the default. And default, since it has a type of never, it is going to throw an error for us, and it's going to say, okay, we can't have this value in our application. And with this, our second challenge has come to an end. See you in the next one. Object-oriented programming, or OOP for short, is a paradigm of programming, or it is a style of programming that is really, really important to understand when it comes to JavaScript, and the same applies for TypeScript as well. But don't worry, I've got you covered. We're going to talk about how we can create classes and objects, and we're going to take a deep dive into the this keyword, which tends to confuse a lot of junior to intermediate developers, how the this keyword is bound, what it actually refers to, in which context it does what. And we're going to talk about all of that in this section as well. And from that point onwards, we're going to talk about classes in TypeScript. For example, we're going to talk about read-only and optional properties. We're going to talk about private and public members, getters, setters, index signatures, inheritance, abstract classes, protected members. And as I discussed that very briefly before during the section introduction for the interfaces, interfaces provide shapes for an object. Classes are object factories. So there has to be some connection between classes and interfaces. And there is a connection. We're going to talk about that as well. Finally, we're going to wrap this section up by talking about generic classes.
Hi, and welcome to the first lecture in object-oriented programming in TypeScript.
First of all, I would like to apologize for my voice. It might sound a little bit raspy since I recently caught a cold, and I'm a lot better now, so let's just jump into this section. First off, what I would like to do is just give you like a very brief definition or like overview of what object-oriented programming is. You might have experience in writing object-oriented code from JavaScript, from your JavaScript background. But what I actually tried to do throughout this section was just to, I'm not going to assume you know anything, so I'm going to start from absolute scratch. Now, object-oriented programming, or OOP for short, is a programming style or a programming paradigm. It's not in technology, it's a way of writing code. There are several other styles of programming like functional, procedural, event-driven, and etc. And depending on the programming language, there are these kind of programming paradigms that they can support. Now, JavaScript and TypeScript, both of them, they can support functional and OOP. Now, object-oriented programming revolves around objects, and we use these objects interconnectedly to represent and hold data. Each object can contain data, which is also called state, and it can contain operations, which is also called behavior. Now, I'm going to give you an example. For example, let's say we have a robot. I actually used this example in my JS course as well, so I'm actually trying to stay consistent with that. And a robot, let's say a robot is an object. And in that case, that robot would have some specifications like its model number, its basic information about its like capabilities. These could be called the properties of robot. And then if the robot can do anything, for example, if the robot can lift something, if the robot can talk or walk or do whatever, then that is going to be the robot behavior. Now, the robot specification is something that we contain with our classes in the form of object properties. And the robot behavior is going to be encapsulated in the form of object methods. Since we are talking about objects, we no longer say functions, we say methods. Now let's create our very first class so you can get an idea of how this actually works. Now, to be able to create a class, first off, we need to write the class keyword itself. And then the name of the class. Class names in TypeScript as well as in JavaScript, they are Pascal case. So first word of every letter has to be uppercase. This is going to be our class of robot, and I'm just going to open up this code block. And within here, we specify what properties this object will have and what methods this object will contain. What will it do? What kind of specifications this robot has, and what does this robot do? Now, you can think of this class of robot as a factory for creating objects. And in a moment, I'm going to show you why object-oriented programming is so useful and how it actually solves the issue of code reusability. And it helps you create this one object, this factory for an object. And then through this, you can create like 1,000 objects. Cool. Now, let's get back to this example. Let's say I want to add an ID to my robot, and the type of the ID is number. So this is a property, and I also want to add a model for my robot, which is going to be of type string, since the model, the way that I'm thinking about it, is going to contain alphanumeric characters. And let's also add a name for our robot, and that is going to be of type string as well. Now, if you do this in JavaScript, it's going to work well, but in TypeScript, we need to think of typing as well. Now, if I just hover on this, it says property ID has no initializer, and is not definitely assigned in the constructor. So it tells us to assign this within the constructor. So what is the constructor? Now, a constructor for an object is like a special method that is used to initialize objects, to create objects for us. And that is the constructor. And the name is actually self-explanatory. It's a constructor for objects. And it allows this class to initialize itself. And the keyword for that is constructor itself. It is nonetheless a function. It's a method. But it is a very special one. And you need to keep in mind that the name has to be constructor. Now within these, I'm just going to zoom in. I think it's zoomed out a little so you can really see. Now within the parameters for this function, we are going to initialize the ID, the model, and the name. And the initialization process is very simple. We are basically going to redo everything right here. So I'm going to say I have an ID that is going to have a type number. I'm going to have a model that is going to be of type string. And I'm going to have a name that is going to be of type string as well. Now that we have initialized these, what I'm going to do is I'm going to open this function. Now, what I'm going to do is I need to provide a relationship between this ID and this ID. And these two are completely different. So later on, when we try to create an object, we need to create a new instance of this robot. And when we create a new instance of this robot, we are required to pass several arguments. What are going to be those arguments? There are going to be an argument for an ID, a model, and a name. So we can create that object. If you have 10 robots, you need to have 10 IDs, 10 models, and 10 names. And that's the good thing about these classes. They allow us to create objects, as many objects as we want. I'm going to get to that in like a couple of minutes. So the way that I'm going to go ahead and solve this is going to be using the this keyword. I've actually dedicated several more lectures to the this keyword, and we're going to talk about it a lot. But in this lecture, I just want to go briefly over this. The this keyword refers to the current object. So what is this class? The class is a factory for objects. In other words, the class itself is also an object. So when I say this, I'm referring to the robot class. So when I say this, and I say robot class, and I am saying the robot class is actually an object, can't I use the dot operator to select its members like an object? We can. So I'm going to say this dot, and as soon as I do that, you can see we have access to all three members. Keep in mind, constructor is a special method. It technically isn't a member of the robot, but you could classify it as a member if you want. But you can see that since it's not being listed in here, we have ID, we have model, and we have a name. Since it is not listed, we can assume that it is not a member. It's a special method to initialize the actual robot. And in here you can see it says robot.id. So as soon as I say this, I'm referring to the robot class. So instead of saying robot.id with a type of number, instead of saying all of those, I'm just going to say this. Cool. So this dot is going to give me access to the first property or the first member of the robot class. And that is going to be ID. So I'm going to grab that ID. Now, when I say this dot ID, I'm not referring to the parameter. Keep that in mind. I'm referring to the property. These two are different. They do have the same name, but these two are completely different. And then I'm going to assign that ID to the ID parameter. And you can see that underline, that red underline has gone away. Now, next up, I'm going to grab the model in the same way. So this dot model, and I'm going to assign the parameter to the this dot model. Again, the first part, this dot, I just explained that very clearly. This refers to the robot. And when I say dot, I'm accessing all of its properties or members. And from all of those, I'm going to select the ID, and I'm going to assign to it this ID of parameter, this parameter ID. And I'm going to do the same thing for the name.
This is going to be equal to the name. And now we don't have any kind of an issue. And within our JavaScript, you can see that we have a class of robot, there is a constructor, and these type annotations, these are actually very strict to TypeScript. They don't have any compiled JavaScript code. And we have this.id equal to id, this.model equal to model, this.name equal to name. And now whenever you see this.id, you immediately know what this keyword refers to. Of course, in the context of this class, a class, and you know what comes after that, what does that refer to? Now, since we have created that, and I'm going to zoom out a little to our previous level, let's actually go ahead and create an object so we can really see how we can create an object from this. Now, to be able to create an object from this class, we need to initialize a new instance of this class. Or, in other words, we need to instantiate it. Cool. And what I'm going to do is, since JavaScript is case sensitive, if I do robot with a lowercase, it's going to be different than this robot with an uppercase. So these two identifiers are completely different. Now, the way that you instantiate something new is using the new keyword. It's going to give you like a new thing. You want to instantiate a new data object. You want to instantiate a new whatever you want, you can use the new keyword. Now, I want to instantiate a new robot object, so I'm just going to say new robot. And as soon as I do that, what is it requiring us to provide? It asks us to provide an ID, a model, and a name. Cool. And where are they coming from? They're coming from the constructor. Why? Because constructor initializes the actual object. So now you can see the relationship of this constructor with the robot and why the constructor is a special method. So the ID, what I'm going to pass is going to be 1051, which is of type number. The model is going to be EX69, and the name of the robot is going to be Avden. And I'm going to save that. So this is actually an object. We can take a look at that. So console log robot, and as soon as I do that within the console, we can see we have an object, prototype is object, ID, model, and name. Now, there is on this robot object that we have created, we can select all of these properties using the dot notation. So if I were to say robot dot, as soon as I do that, I could select the ID, and that's going to be the ID. I could select, using the dot operator, the model as well. Now, I've just shown you how you can add properties to this class. But what about methods? How would you provide methods for your class? And in other words, provide behavior for your class. So far, except for this type annotation, nothing is different between the JavaScript and the TypeScript code. It's pretty simple. If you have experience in this area, it's going to be all very, very simple. Now, within a class, we are not going to write the actual function keyword itself. So since this is a method, I'm just going to name this walk. This is a walk method. Now, before jumping into here, the constructor itself doesn't have a return type. Keep that in mind. Why? Because the constructor returns the robot object itself. That's why we don't type annotate the return type of it. We don't say void, we don't say anything, we just let TypeScript infer that, because TypeScript knows that this constructor is going to return this robot class for us. That's how these two are actually connected. So getting back to the walk method, I'm going to say void, since I don't want to return anything and I just want to console log something. I'm going to say console log, this robot can walk, and that's it. And as soon as I do that, let's take a look at our object. We don't see this method right here. And there we go. The method is within the prototype. And the name of the method is walk. Now, instead of jumping all these levels down, how would you actually go ahead and call this method on this object? It's in the same way that you call any method on any object. You grab the object itself, you do the dot notation, and you can see that member is now color purple. And this member, and this represents, so the blue ones, the blue cubes, they represent properties, and the purple ones, they represent methods. And as soon as I do that and I actually call that and save it, we are going to see that it says this robot can walk. So I'm going to hit the pause. I'm going to just wrap this lecture right here. But before wrapping, there is something else that I would like to tell you. In case you create a class and you create 10 instances of that class. So you have robot 1, robot 2, robot 3, whatever. And each robot has its own specifications. But you are wondering, okay, which object is actually an instance of which class? How can you actually make that check? Now, in JavaScript, we have a type of operator that gives us the type of any data type. So if I do type of robot, it is going to give me an object, and there it is. Let me just enlarge this a little bit. So it gives me an object. I know that is an object, but how would I find out if this robot is an instance of this robot class? There is actually another operator for that as well. So for that, we are going to use the is instance of, ironically, operator. So I'm going to say, write the object itself, and then I'm going to say is instance of, and then the class name. And as soon as I do that, let me fix this is instance of. Is it okay now? Why is it not? Can't find is instance. Oh, sorry. It doesn't have is. It's just instance. Instance of, and there is no uppercase O. Let me just get rid of that. There we go. Finally. And it gives us a Boolean expression, a Boolean value, not expression. And we know that this robot is actually an instance of the robot class. Now, if I change this to robot 1, we do have this thing that, did you mean robot? It's not accessible, but it's not going to be like an instance of that. Robot 1 is not an instance of the robot. We can actually check that within the JavaScript. So within here, if I just say 1, and as soon as I save that, robot 1 is not defined at. So whatever, if I just do, for example, let me show it to you so this actually works. Let robot 1, I'm going to set it to this empty object, and then I'm going to pass in robot 1, and I'm going to save it. You can see we get false. Why? Because robot 1 is not an instance of this robot class. So everything is making sense so far, right? And with this, our lecture comes to an end. See you in the next one. Hi everyone. In this lecture, I would like to talk more about this keyword. So in this lecture and in a couple of upcoming lectures, we are going to talk about stuff that are going to allow us to better understand this keyword and different contexts, different scopes and we are going to take a look at how this keyword is going to behave. So a common usage of this keyword is with the 3 methods that we're going to cover in this lecture. The call method, the apply method, and the bind method. And we are going to see how they actually interact with this keyword. I'm going to start very simple, and then as we move on, we are going to cover more and more topics. First off, I would like to create a person object, if I can type it correctly. And this person object it's not going to be a sophisticated object. It's just going to have one method, and that is going to be called object func. So we know what it is. It's not going to return anything, so the return type is going to be void, and the only thing that it's going to do for us is going to be to console log something. So it's going to be log. First off, I'm going to provide an indication that this is actually an object. And then I'm going to pass in here this keyword. So everything is cool so far. So we have this keyword there. Now, how would I go about calling this function? First, we need to reference the object, and then using the dot operator, we can call this function. And as soon as I call that, we can see that since I shouldn't have actually saved that, I should have actually shown you and then saved that. I need to check something within the tsconfig file. Strict mode is true. Still this keyword, yeah, it is going to work here. Now this keyword, it always refers to an object. but how it refers to an object depends on how the this keyword is called, or when or to what object it refers to is how the this keyword is called. The this keyword is usually called within a function, but it refers to an object. Now, this function, object func, this is within the person object. So this function is a member of this person object. So technically, when I say this keyword, it is referring to this person object. And instead of saying person, we are just going to say this. Now the first case is very clear, right? And I'm just going to say 1 right here, so we can keep track of what it is we are trying to do here. I'm going to keep that there, and I'm going to move on to the next one. You can already see the compiled JavaScript code as well. For our next example, I'm going to talk about a function, just a very simple function. And this function is going to grab 2 numbers eventually, but for now it's not going to have anything, and it's going to return void. And what I want to do is I want to log something to the console with this function. First this string function, and then the this keyword. We can already see there is a compilation error, and we are going to get to that, don't worry. Let's call the function, and I save it, it doesn't matter because there is an error. Now the reason that there is an error is it's because this keyword doesn't know what it is that it is trying to refer to. TypeScript doesn't know what the this keyword is in this context because there is no object. Now, it was very easy for TypeScript to understand the this keyword in our previous example, but it's not that easy in this example. And it is telling us that it has a type of any because it doesn't have a type annotation. Because it can't know what it doesn't know what the type of this keyword is. It doesn't know what this is. Now, to actually get around this, there is a bad practice that we can do, and that is turning off the strict mode, which I am going to do. But in our, I think in our second lecture from this one, is where I'm going to show you how you can actually type annotate the this keyword as well. But for now, we are just understanding the this keyword. There is a lot more to know. So for now, I'm just going to do this bad practice, and I'm going to turn this off so we can actually study the this keyword. And as soon as you do that, since the this keyword is not bound to any kind of object, what is the main object that it bounds itself to? It binds itself to. It is the window object. And that is why from the function, we get the window object. And we have all of these methods and properties on the window object. And you're familiar with that. So when it doesn't have any binding context, it is going to bind itself, or it's going to attach itself to the window object. That's basically what we mean when we say bind. So that was the second one. Let's take a look at our third case, which is going to be a class. We talked about an object, we talked about a function, but how would the this keyword react when we were talking about a class? So class is going to be called test because it is actually a test. And within here, I'm going to define a method that is going to be class func. It's not going to return anything, so type is going to be void. It's just going to write console log the string of class as well as the this keyword. We already know what the this keyword is going to refer in the context of this class. It's going to refer to the class. And if I hover on it, and you can see it has type annotated it correctly, that's why there is no error. Even if I just say true, it's not going to throw me any error right here. There is going to be this error. If I just save it, there we go. There is that error, but there is not this error. So let's go back. I'm going to show you how you can fix that so you don't have to turn off the strict mode. Cool. Let's instantiate this class. So test is going to be the object. New test. Keep in mind case sensitivity. And we don't have a constructor, so we are not going to pass in any parameters. And as soon as I do test dot, we are going to access the member class func. Let's call that. And as soon as I do that, we can see that this keyword refers to the class. There we go. It is an object, of course, as I told you in our previous lecture, but we can see that this is actually the test class that we have created right here. So far, there were no surprises. We knew, except for the second case, because there wasn't an object in sight. For the second case, there was a surprise for you maybe, and it actually bound itself to the window. And what I'm going to do is for the rest of this lecture, we're going to talk about the second use case. So it should have been better if it should be better if I named that 3 and this one 2, and I just cut that and put it right after the class. So our third case is going to be the case that we're going to explore further. Now there is a method called the call method. The call method's job is actually to bind the this keyword. Now this function doesn't have the this keyword. We already know that. And what I would like to do is I would like to comment this one as well. So we just have that function. This function doesn't have the this keyword context. It doesn't have the this keyword binding. And for that reason, what we could do is we could use the call method. Now the call method, the way that it would work is that we are going to pass in a reference to the call method. Now, I've already talked about how functions are actually called in TypeScript and JavaScript. We first write the name of the function that we want to execute, and then the parentheses that are going to execute the function. But in this case, we are passing a reference to our function, or we are referring to the addition function, and then we are going to call the call method on it. Now the call method requires us to pass something. Cool. And what I would like to do is, if I just save that, and as soon as I save that, we can see that there is nothing happening here. And what I would like to do is I would like to pass in an object. And this object is going to have a name, a key of name with a value of John. And as soon as I do that, something very interesting happens. Since the call method binds the this keyword, and we know that the this keyword can only be bound to an object, it binds it to the object that we have just passed in here. Now, this function now has a this context. And what is the context? It is this object that we have passed right here. So when I say this, it refers to the object that I've passed in right here. And you can see that even though this function requires no parameters, we have not added any arguments to the addition function. This is an argument for the call function, call method. Cool. Now this call method, again, it binds the this keyword to an object in the context of which we have executed or referenced our function. Now this call method, it could also accept parameters. You could provide parameters, but those parameters are going to be the addition parameters. They're going to be the addition functions parameters. So if I just comment this one out, put it down below and uncomment this, and let's say we have the parameter A that is going to have a type of number, and the parameter B that is going to have a type of number as well. Let's take a look at, I don't know, like A plus B. We could take a look at that. And now what we are going to do is we are going to pass in the value for A and the value for B in our call method. So I'm going to add in a comma, and as soon as I do that, it could be any number. So I'm going to say 10 and 50. And as soon as I save that, let's take a look at that. Now, before providing that, what do we have? We have not a number. It is not a number. Since it doesn't throw us an error, keep that in mind, but it says not a number because A plus B, it's like, even though they're of type number, they can be like added together. So let me just move forward. There we go. And let's save it. So the first thing is function, which is right here, the string. Then we have the this keyword, which refers to this object. And then we have A plus B, which is 60. Cool. So far, everything is making sense. Now let's move on to the apply method. I'm going to save that. I'm going to keep the function definition as it is. And the apply method is basically does the same thing. The only difference, and you need to keep this in mind, between the apply method and the call method is in the way that we pass in parameters. When we are talking about the apply method, the parameters, they're going to be passed in an array. But in the call method, we just pass them like this, like 10, 50, whatever. But in the apply method, we can pass parameters as an array. So first off, let's actually take a look at the apply method. Again, I'm referencing the function, but I'm not calling that. Keep that in mind. What I'm going to call on the function itself is going to be the apply method. And I'm going to pass in an object of, again, with the same thing, like John. And as soon as I save that, we basically get the same thing. And we do get that and not a number as well. So if I just say, okay, I'm going to pass in 10, you can see that it says type error. Why? Because it says that called on non-object. What it basically is trying to tell us is that we need to pass in an array. So if I convert this to an array and I save that, we still get not a number because we're trying to add 10 to b, which both of them are number. That is going to result in not a number. And if as soon as I pass in like 32, we still get that. Let's do 10 and 32, we get 42. So even though it doesn't accept, this function does not accept an array, we have to pass in the arguments. So if there were like 2 more arguments, all of them would be passed in within this array. And that is the only difference between the call and the apply method. Now, the bind method is, before that, the apply method, again, it binds the this keyword of a function that doesn't have the this keyword to an object, and that object has to be a context in which the function is being referenced or being called. And this is the object. So in both cases, we can see name John. And this is if you are wondering how you can provide this keyword to a function, there has to be an object involved. Let's move on and let's go to the bind method. The bind method, it binds again the value of the this keyword to the function, and the difference is that it returns a new function. And we need to invoke that new function if you want to take a look at this keyword. So let's take a look at this. What I would like to do is I would like to create a variable that is going to be operation 1, and I'm going to pass in a reference to our addition function. Now on this reference, I'm going to call in the bind method. And as soon as I do that, what we are going to provide is going to be the same thing as the call method. We're going to provide in an object. And let's save that. And since we are not logging anything to the console and we are not calling this addition function, that's why there is nothing here. Now, you might be asking, okay, there is a console log right here, but we are not executing this function. This is a completely new function, and we need to execute this if you want to take a look at the result of this. So I'm going to say operation 1, and let's save this. And now we can see that we have the name John, and we have that not a number. Now, in this context, in the context of the bind method, the way that we are going to pass in arguments is going to be exactly the same way as the call method. So it's going to be like 25 and 35. And save that, we are going to get 60. We can also create another function from this as well. And I'm going to call that operation 2. And that could be like 250 plus 350. And we could call it right here as well. And now it's going to be like the second time, 60 and 600. So now you know everything there is when it comes to how this keyword is going to interact with the call method, the apply method, and the bind methods, as well as how this keyword is actually interacting with an object, with a function declaration, as well as a class. You have all of that knowledge. Now, the only thing that is remaining is a special type of creating functions, special way of creating functions, and that is arrow functions. Since arrow functions, I'm not going to give away like the lesson, but we need to actually talk about arrow functions and how they interact with this keyword. What happens in that case? But before jumping into arrow functions, there is a sort of side lecture that I've prepared, So you can actually you have all the tools to understand, all the prerequisites to understanding a concept called lexical scope. And before diving into lexical scope, there is like this idea of scope and what the scope is, how it interacts with our variables. And first I'm going to talk about that, and then we are going to talk about lexical scope, arrow functions, and how arrow functions are actually a good thing. So see you in our next lecture. Let's talk about scope. Scope is where a variable is accessible. In this lecture, we're going to talk about the global scope, the local scope, aka function scope, as well as the block scope. Let's talk about the global scope first. Now, the global scope is the scope of this entire file right here. This for a brief overview of scope.ts. This is the global scope. Any variable that is defined within the global scope can be accessed in any function and in any array, in anything that in any loop, in anything that we want. And they're globally accessible in simple terms. I'm going to take a look at another keyword for creating variables, a legacy of JavaScript, and that is the var keyword. So far we have created variables using the let and the const keyword, and I'm sure you have seen this var keyword, so I'm not going to pretend that you don't know what var is. I'm going to create a variable that is going to be my name. Let's type annotated string, and that is going to be John. And if I take a look at that, we are going to see that we have access to my name in the console. It says John, and it wouldn't matter if this variable has been assigned with the var keyword or it has been assigned with the let keyword. In this case, it's going to be the same thing, and even if it is assigned with the const keyword, it's going to be the same thing. And this variable could be accessed within a function as well. So if I say, okay, my name is John, my name, let me just say name. So in here, what I could do is name. I've already declared that somewhere. Let me just change it to some name. And in here, console.log my name. As soon as I do that, let's actually call the function some name as well. We're going to see two Johns. So one is coming from line number 6. The other one is coming from line number 3, which is like this line. So we have access to this my name variable. When we say we have access to it, it means that we have actually access to its value within a function everywhere that we want. So this is basically global scope. It's very simple. Most of the times you don't even think about it. Next up, we have local scope. This is where things get interesting. And I should probably add this to the global scope as well. Let's save that. Now, a local scope is the scope of a function. The var keyword is locally scoped, or its scope is limited to a local scope, but the let and const keywords, they're block scoped. And we're going to explore that further in this lecture. Now, what is a function scope? Suppose we have a function that is like my func. It doesn't do anything. It doesn't return anything. I could say void. I could just leave it as it is. And in here, let's say we have a number. And that is going to be var num has a type of number, and it's going to be 10. Now, if I say console log num, come on, buddy, console.log num, we are going to have access to it, my func. Let's save that, and we're going to see 10 on the console. And it wouldn't matter if I have var, if I have let, it's going to be the same thing. Or if I have const, it's going to be, const, it's going to be the same thing. Because var is actually function scope. Now, because var is function scoped, we can't have access to the variable num outside the function. So in here, if I just do log num, it's going to say, what are you talking about? Cannot find name num. Why? Because the name num was defined, this identifier is only available within this block of this function. It's called local scope or a function scope. Now, it's going to be the same thing with let and const, but for a different reason. Now, the reason that we don't have access to this variable using var is because var is function scope. But the reason that we don't have access to it using let either is not because let is function scoped, because let is block scoped. And what is this that I've just highlighted? This curly brace and this one. Doesn't it represent a block of code? It does. So that's why let attaches itself to this block. And it doesn't matter where that block is. It could be like thrown casually around in your code, and let would still get that block and would make it a scope. So I'm going to just leave the var right here, and then that would bring us to our third and final scope of this lecture, that is going to be block scope. Now again, as long as it is a block, if you specify a variable with let is going to convert that block into a scope. And a scope is where that variable is going to be accessible. And that's it. So it may look like JSON, but this is how we are going to work with it. So I'm going to create a variable with all these three keywords, var, let, and const, and then we're going to go over the differences. I'm going to say num1, so we don't run out of numbers. This is 100. Yeah, I'm just going to keep it at that. Let's change this to, and another issue of var, which I'm not going to discuss at all in this lecture, is that when you create a variable with var, you can actually create another variable with the same name, which is just silly. I've already talked about this in my modern JavaScript ES6 and beyond, excuse me, playlist on YouTube. You can just go ahead and take a look at that further. But I'm not going to talk. That is actually another difference between let, between let and var. Why var was replaced with let and const. And I'm not going to go over that because we're just sufficing to the topic of scope. We're just going to talk about scope. So we have these three variables, and I'm going to say console log. Let's grab, let's say var, and I'm going to say num1. This is going to be num2, and this is going to be num3. So num2 is with let, and num3 is with const. And as soon as I save that, let's save this, let's say 200 and 300. Of course, we are going to see that. That's obvious. And let me just comment out this line as well. We have var 100, let 200, and const 300. Now the thing with let and const is that if I comment these two out, you know what? I'm not going to comment them out. I'm just going to keep them as they are. Now, what happens if I try to do inside block, something like that? So I'm just going to click Alt, hold Alt, and say inside the block. So it is really understandable. And this is going to be outside the block. Now, since var is function scope, it doesn't have any other scope. So it doesn't matter if you write it in a loop, if you write it in a block, it's going to basically ignore that. That's why we have access to it outside of the block right here. Var outside the block, we have access to that variable. Now that is not something that we want. That's why let and const are created, because for some reason you have like a lot of code and you have created a for loop. And for some reason you forgot what variable for that for loop was, and you can incredibly easily change that for loop. But that thing is not going to happen with let and const. So if I just copy this, put it down here, as soon as I do that, it says cannot find name num2. And it doesn't matter how many times I say outside. Why? Because let is going to attach itself to this block. And this variable num2 is only accessible within this block. It's not accessible outside of it. And when it is accessible within this block of code, you can have a variable, you can have two variables with the same name. There we go. And you can have it outside as well. And the same goes for const. And it's going to say num3. So this is the difference between global scope, local scope, and block scope. And this is why we no longer use var, but it is something some people still prefer using it. This is why we are actually trying to move on from this keyword once and for all, and why there are so many issues with this instead of the let and const. I'm going to comment out these two lines so there is no error in our code. Now that you understood what scope is, what are the three primary scopes, in our next lecture we're going to talk about arrow functions and the lexical scope, and then we are going to come back to the this keyword. This is all because of the this keyword. Hi everyone, let's talk about lexical scope and arrow functions. Lexical scope is where we have access to a variable from the enclosing scope within the enclosed scope. Let's take an example of that. Take a look at an example of that. First, we're going to talk about the lexical scope, and I'm going to explain it, and I'm going to tell you what that is. And then we are going to tie it back to the this keyword through arrow functions and what arrow functions actually have solved for us. What kind of hack? What I would like to do is I would like to create a class. Let's get back to creating our classes. And in here, what I would like to do is I'm just going to say my product. Doesn't really matter what the name is. So we have this my product. And in here, I'm going to create a variable. I'm going to create a function. Since we are talking about lexical scope, I'm going to create a function. And this is going to be online course. This is a method. And I'm not going to type annotate it since we are going to do a lot of crazy stuff in here. I'm not going to type annotate it. Let's create a variable that is going to be product. Okay, product name. And the type of it is going to be string TS bootcamp. Let's save that. Let me write the name correctly. Perfect. So we have this product name. And within this method, online course, what I would like to do is I would like to access an API. And that is basically a web API or browser API called setTimeOut. Now, the cool thing about setTimeOut is that it requires a handler or a callback function. So what I'm going to do is I'm going to pass in a callback function right here. And then after I've passed the callback function, I need to give it like a range in time, for example, like 100 milliseconds, like time. So it is going to invoke that function after that time has been elapsed. So I'm going to say like 100 milliseconds. And in here, we're going to have a basic callback function, regular callback function, nothing too crazy here. And I'm going to say console.log. And as soon as I do product name, what do you think is going to happen? Since we are within the scope of this online course, lexical scope says that if there is a variable created within the enclosing scope, is also called the parent scope, it can be accessed within the enclosed scope or the child scope. So technically I have access to the product name. And when I save it, you can see there is no error. It means that we do have access to that product name. We can also take a look at it in the console. Let product equal to new product, new my product. And I'm not going to pass in anything. And let's say product dot online course. Let's call this and save that. There we go. We got TS Bootcamp. So we do have access to it, and this is it. This is lexical scope. But lexical scope is a one-way street. We do have access to variables from a parent scope within a child scope, but we can never access the variables from the child scope in a parent scope. It is not like the other way around. So if I were to say let, or I'm gonna like keep it simple, you know what, I'm just gonna say let new product, and this is gonna have a type of string. I'm gonna say Tailwind CSS Bootcamp, and I'm gonna pass in that here as well, new product. And as soon as I save that, we can see that we have TS Bootcamp and then we have Tailwind CSS Bootcamp. But what do you think? Do we have access to it? No. Why? Because that's what lexical scope says. I'm going to say new product, and I'm going to spell it correctly. And as soon as I do that, it says, what are you talking about? Did you mean product? Did you mean this? Did you mean that? So we can have access to it. And I'm going to keep it there for your reference. Now this is lexical scope. Let's tie it back to the arrow functions and the this keyword. Now, what happens if I try to console log the this keyword within the online course method itself? I'm going to say log this, and we already know what this is going to give us. This is going to give us a reference to the class itself. And as soon as I save that, we can see there is a reference to the class itself, since that is the object, and this keyword refers to an object. How or why it refers to an object is what we talked about in previous lectures, and we know that this refers to this object. But what happens if I invoke this keyword within this child function? What do you think is going to happen? You can pause the video and like think about it for like a few seconds. What would happen is that this keyword is always looking to attach itself or bind itself to an object. But there is no object in the context of this callback function. So it requires an object. It can't get an object. So what does it bind itself to? It is going to bind itself to the window object. And as soon as I save that, we can see that right here. We got the window object, because at the end of the day, this keyword requires an object. And the reason that this works is, remember, we have our, where is tsconfig? We have the strict mode to false. And we are going to fix this, so don't worry about it. That's why this works. Otherwise, the strict mode is not going to allow you to do this, which is a good thing. Now, if I just do, you know what, I'm not going to touch the strict mode. I'm just going to leave it as it is. So even though it might be confusing at first sight, that even though I am within the my product class, why can't I access why the this keyword can't access my product? Because the this keyword has not been executed within the context of the my product. It was executed within the context of the online course. And that is why it doesn't work that way. Now, if I were to change this callback function, I could just like copy it down below, and I'm going to comment this entire thing out so you have it as a reference. Now, if I change this to an arrow function, in that case, what do you think is going to happen? And that is the beauty of arrow functions. Now, within this arrow function, we're not going to need those two, and I'm just going to keep it simple. So I've not saved anything. What do we have? We have that product name. I could comment it out, so we are just focusing on the this keyword. Now, as soon as I save this, since the this keyword is looking for an object, it's going to attach itself or bind itself to my product. And let's save that. There we go. So there is a console log on line number 6, which I'm going to comment out. So there is only one console log right here, my product. And what actually happened here? Why is the function, the function expression different than this arrow function? And that is because of the nature of arrow functions. And I think that is one of the great beauties of arrow functions. And arrow functions actually don't have the this binding. They have no clue what the this keyword is. But this function keyword itself, it knows what the this keyword is. But arrow functions, they have no clue what the this keyword is. That's why when you say console log this, the this keyword passes right through this arrow function because there are no limitations on it, because the arrow functions doesn't know what the this keyword is. It doesn't have the this keyword binding. So when it passes through the this arrow function, when the this keyword passes through the arrow function, what does it find? It finds my product. The reason that it couldn't find it in this scenario was because the function itself didn't let it pass. It forced it to show some value, and since there was no object in sight, the this keyword just grabbed, it was like a natural reflex. It got the window object, and that's what the this keyword is going to do. So if you force it to say something, it's going to revert back to like big, I don't know, whatever. I'm not going to say anything else in this regard. So it's going to go back to its original origin. And that origin is the window object. But since arrow functions have no clue of this keyword can easily attach itself to my product. So if you have this console log right here, or if you have it within the method itself, there is no difference. Because arrow functions, again, do not put a block under this keyword, like do not force it to tell me something. So this is the cool thing about arrow functions, that they don't have, this could be a limitation as well to where you can use arrow functions and where you should avoid using arrow functions. So when it comes to the context of these kind of classes, you should know how this keyword is going to react. Because this is going to, excuse me, this is going to prevent you from getting frustrated, getting confused. Why this keyword is not showing me the window object. What is happening here? Again, the this keyword doesn't have the this binding. Arrow functions have no this binding. That's it. And there used to, I did talk about a hack during the start of this lecture, and I did say that there used to be a hack. And that hack was like this. So I'm going to comment this one back in. I'm going to copy it. I don't know why it is happening like that. There should be some space there so you can really understand what is happening. There we go. So I'm going to copy this. There is actually a hack that you can fix this keyword binding with these kind of functions. I'm going to get rid of these two since we don't use them. We don't need them. Now, what we would do initially was that we would create a variable like let self, since a class, it refers to the class itself. We could say self is equal to this. Now, this self is in the context of this method for this my product, and we know that this keyword in here, it refers to my product, and then we would refer to this self within this function, and in that way it would come back, it would like do 180 and it will return, it would get back to my product. Now this is a hack. You might also see like it used to be like self, or I don't know, like in some programming tutorials they do that. So let that, it's ironic, so I guess that is where the joke lies in. Let that equal to this, and you're going to grab that. Instead of this, you're going to say that. Like function and that class. Like it's for, that's why it says that. So in both cases, you could do whatever, like self-created this keyword. And this is a hack, as you can see. We have this extra line that you have to keep in mind and that you have to work with. Now, this issue is solved with arrow functions. So if you use arrow functions with classes, this keyword, no matter how many levels nested it is, it's always going to refer to the object, it's the class, the object class itself. And with that, our lecture comes to an end. And I do feel like you might be thinking, okay, now I know that this keyword, how it reacts. But what good is it in real world? So what I would like to do is I would like to dedicate another lecture as well. And for that lecture, I'm just going to show you like how you can use this keyword to manipulate the state of DOM. So that's what we are going to talk about in our next lecture.
we have sort of vaguely talked about this keyword, and even though we know how it works and what it refers to, I thought it would be beneficial to study a more of a real-world example of how this keyword is necessary. So first of all, what I would like to do is I would like to jump into our HTML file. In the HTML file, I'm going to add an image. Let me just bring it up here. And I'm going to insert that image right here. This is an image element. And this image element, I am actually going to provide some styling for it. The image is within the same directory as the HTML file. So I'm just going to say, I'm just going to write the name of it. And I'm not going to do anything for the alt. After the title, let's add a style element. And here is our image in case you're wondering about it. I'm going to zoom out so you can really see this is the image. Now, through this image, through the manipulation of DOM, I'm going to show you a real world example of this keyword. But first, I need to apply some styles on the image. The image is going to have a height of 400 pixels, a width of 450 pixels. Object fit is going to be cover. If you don't know what these are, don't worry about them. These are CSS, and I do have actually 3 different courses on 3 different aspects of CSS. Since CSS is such a big and integral part of web development, you can check any of those courses out if you just go to my profile. And let's move on. I'm going to add a filter effect to this image, and that is going to blur the image by an amount of 10 pixels. And as soon as I do that and save it, you're going to see the image is getting smaller and it is actually blurred out. Now it is 100%, the zoom level. And I'm also going to add a transition, 0.25 seconds. I'm going to create a dynamic class within CSS that is going to be unblur. The aim of this class is basically to get rid of the blur effect, and it is going to be implemented in our JavaScript. So blur is going to be 0. Now that this is done, let's head back over to our TypeScript file. Now, I'm sure you are familiar with how you manipulate DOM with JavaScript. It is almost in the same way, implemented in the same way as with TypeScript, except we have that type annotation going on for us. So first of all, I'm going to create a variable called image, and within this variable, I am going to provide that, excuse me, I'm going to grab that image that we have in our HTML. So I'm going to say document.query selector. This is my preference. Using the query selector, I could add a class to our image, so the selection process is going to be a little bit more intuitive. I'm going to say img is going to be the class. So I want to select an element that has a class of img. Now, as soon as I do that, it looks like JavaScript. We did not type annotate it. We have to type annotate this. Now, what kind of element it is that we're selecting? It is an image HTML image element. And that's exactly the type. So if I hover on it, you can see it says element. It doesn't quite know what that is. So I need to type annotate it. I'm going to say HTML, and then I have all of these elements, and I'm going to select HTML image element. And there is something that you need to pay attention to. Since TypeScript is very strict about null and undefined, there might be a situation in which you actually incorrectly select that element. Now, in this example, we have imag, which is the class name. However, I have written img, and we know that these two are different. We have an extra a there. So this document.query selector is not going to return an HTML image element. It's going to return null. That's why there is an error there. It says type HTML image element, or operator, or the union type is not assignable to type HTML image element. We need to type annotate it correctly. Therefore, I'm just going to add this as a union, and now the error is gone. So document.querySelector either returns an image or it returns null. Let's fix that class name as well. So it does return an image. Now this is the difference. Cool. What do I want to do in this project? When I hover on the image, I want the blur effect to go away and I want to see the image. But when I move away from the image, I want to see the blur again. So it's like on and off of the blur. So I need to do something on this image. I'm going to grab our image element and I'm going to add an event listener to it. Now, by default, it's going to add the optional chaining, but I'm going to remove it. And then I'm going to explain to you why we need that optional chaining there. So I'm going to say add event listener. What is going to be the type of event? So far, it's the same as JavaScript. We are going to say mouse enter. This is the type of event. And then as soon as this event is listened for or it has been caught, what do you want to do? Whatever I want to do, I'm going to capture that logic in the form of a function. So I want to unblur the image. That's why I'm going to create a function that is going to have the name of unblur image. Let's create that function, unblur image. And this function, I'm just going to pass in the event object itself. The event, we need to type annotate it to the event object, capital E. And then let's just log the event first and let's save it. Now, nothing is being compiled to JavaScript because we have an error. And what that error basically says is that the image variable that we have stored the image element in, it might return a null for us. Object is possibly null. It might be an HTML image element, but if I have mistaken the class name, it might be null. So what we have to do here is we have to tell it to just consider that this is an HTML image element and it doesn't return null. So we need to short circuit it. If the circuit is completed, it means it is going to check for HTML image element, and then in the next round, it's going to check for null. But as soon as it checks for the HTML image element, I'm going to cut the circuit right there, which is called short circuited in JavaScript. I'm going to short circuit it, and I'm going to tell it not to check for null. Check for HTML element, image element, but do not check for null. That's what short circuiting in this context means. That's what I want to do here. So we can short circuit this type checking using the optional chaining operator. The optional chaining operator, excuse me, is, I do sound like a dying walrus in case you're wondering. I heard that recently online, and that is a fitting description of the way I sound. Now, the optional chaining operator is actually a question mark followed by a dot. And this is going to tell the the TypeScript compiler that we are short-circuiting the type checking. We just check for HTML image element and we don't check for null. Cool. So I'm going to remove the dot. I'm going to add the $sign, and then I'm going to add the period. And that's it. Now this checking has been short-circuited. And it's not going to check for a null value. Keep that in mind. And as soon as I save it, everything is not going to be transpiled to TypeScript because I have not actually run the server. Let's run the server, and there we go. Everything is in here, is been compiled to JavaScript, and you can see we got this void here as well. So moving forward from this topic, let's take a look at our event. Since the event has not been fired, we don't see anything in the console. The event is going to be fired as soon as I hover on the image. So I'm going to zoom out so you can really see. So as soon as I hover, there we go. This is our event. This is a mouse event. We got a lot of info right here, which I'm not going to bother because we are not interested in that. We are just interested in this event. Cool. So it is logging the event. But what does this, all of this has to do with this keyword? Let's get back on track. What happens is if I, instead of event, I log this? What do you think is going to happen? And now keep that in mind. I'm going to console log the event as well right here. But before doing that, I'm going to jump into the TypeScript config file, and I'm going to turn on the strict, because that is the recommended setting, right? And as soon as I do that, and I told you I'm going to teach you how you can type annotate the this keyword, and it throws an error. I'm going to take a sip of tea and just go ahead and read what the error says. So the error basically says that it is going to receive a type of any because we have not type annotated it. Now the type annotation of TypeScript for the this keyword is within the function definition. It may look like a function parameter, but it is not a function parameter. Cool. Let's move forward. So in here, I'm going to say that the this keyword, what does the this keyword refer to in this context? So as soon as I say function unblur image, what does it refer to? It refers to the current image. What is the current image? What is its type? We have specified that it is the HTML image element. So I'm going to copy that, put it right here, and I'm going to separate that with a comma. And voila, everything is working correctly. Let us save this. And now you can see we got the event, and we also have that. Let me, the this keyword is basically the image itself. So both of them in this case, they're referring to the same thing. I could just cut that. I'm going to get rid of the event from here as well. Let's save that. If I hover on it, you can see we got that mouse event. Because the this keyword refers to this image, and the event also refers to this image, so in both cases we got the same thing. Now, even though this has this parameter, it is not a parameter. This is just what TypeScript has decided to put the type annotation of the this keyword. It is not a function parameter, not a parameter. Keep that in mind. Now, the this keyword in this context refers to the image. The reason that this refers to the image is because the image element is what is calling the add event listener. And then it is calling this function as a callback function. So this function, I told you, you need to take a look at the call site if you want to find out what this keyword refers to. Where is the call site? The call site of this function is right here. We are calling the function here. And what is this function being called in the context of? It is being called in the context of this image. That is why the this keyword refers to this image. And as I hover on it, you can see we got that mouse event. Now, what is the benefit of this? Now, instead of saying image and then add a class or remove a class, we could just use the this keyword. And I'm going to show you how you can do that. Now, let's get back to the actual application and let's finish it up. So I want, when I hover on it, to remove the blur. Technically, I want to unblur it. I want to append this class to it. So I'm going to say this dot, I'm going to tap into the class list, and then I'm going to add a class. What is that class? The class is right here. It is the unblur class, which unblurs the image. And I'm going to pass it right there. Keep in mind, no dot, because we are within the realm of classes. The reason that query selector requires a dot is because it is not known that you're selecting an element by ID or class or element or pseudo class or whatever. But in the realm of class list, we know that it is a class. That's why we don't provide a dot. And let's save that. Okay, let me save that. What is happening in this keyword? All right, so we do have an error in another file. It is this keyword the third file because of that strict mode which is actually on. That is why we got that error. So where is it? It's right here. So I'm going to comment this one out, save it. We still have, you know what? I'm going to comment the entire function, and there is still these two. Let us comment these two out as well. Oh, come on. I'm going to comment these two out, and there we go. That's it. We got that error. And as soon as I hover on it, you can see we got the actual image. But there is another issue. And that is when I hover away, I want to see the blur again. So let's create a function for that. Now you can create an add event listener in the following manner as well. So we got image.add event listener, and you can see the optional chaining operator is being applied by default. Cool. And I'm going to say the event is going to be mouse leave, the mouse leaves, and then I'm going to run this function, this anonymous function. And this anonymous function is going to have the this keyword. So the this keyword is now being called in the context of this image. So the type of it is HTML. Where is the image? HTML image element. And then, okay, let's colon. It could be an arrow function as well, but the arrow functions don't have the this binding. So I'm going to say this dot classless dot remove unblur. Save that. Everything is back to normal. So I'm gonna hover on it, it unblurs. Hover away, it blurs again. So see, it's like an application. Very, very cool stuff. And now you have like a little sense of how the this keyword ties into TypeScript and how TypeScript ties into actual browser. This is actually running in the background. Keep that in mind. And I think that's it. That's everything you needed to know about the this keyword, and also a real world example of the this keyword. And now you're a master of this keyword. Wherever you see it, if you just sift through the code, you're going to understand what the this keyword is in that context and what it refers to in that context. So that's it for this video, and let's move on with object-oriented programming in TypeScript. Hi everyone, in this video we are going to talk about read-only and optional properties. Now back in our first lecture of this section, we talked about classes, and then I got sidetracked and I just started talking about the this keyword, and I dedicated several lectures to it. Now that that is out of the way, we are going to get back to object-oriented programming. I'm going to go over this class in case you have forgotten that, but I'm sure you have not, but still I'm going to go over it. We created a class using the class keyword, and the class name is robot. It has 3 properties. Classes can have properties and methods, and properties and methods, they're called members of the class. We got an ID property with the type of number, a model with the type of string, and a name with the type of string as well. Now we needed to initialize these. That's why we created the constructor and says this.id. This.id refers to the ID of the class. We assign it a value of this ID, which has a type of number. So this parameter, which is this one, is being assigned to the this.id, and the same goes for the other two. Now these were members, these were properties. We can also have methods for classes, and this is our class. Now a class is a blueprint for creating objects. So from this class, technically you could create 1 million objects. And we did create one object right here, and technically it's called initializing a class, or instantiating an instance of this class or a new object. You could say whatever, however you want. And now in this lecture, we are going to talk about read-only and optional properties, which are concepts that we have already covered when we talked about objects. And that's why they're relevant they're still relevant when we talk about classes, because classes are actually a factory for objects. And a read-only modifier would suggest that we are not able to change the value once we assign that value. That's what the read-only modifier says. Now, the ID for the robot is 1051. Keep that in mind. And I'm going to change this from a normal property to a read-only property. And for that, you just have to write read-only in front of the property itself. Now, if I attempt to change this ID, how would I do that? I'd have to first pass in a reference to this class, which is this robot. So I'm going to say robot, and as soon as I do the dot operator, we get access to all the members. The blue ones are the properties, and the purple, I want to say purple or pink, you be the judge, they are the methods. So I'm going to grab the ID and I'm going to set it to 1050. And as soon as I do that, there is an error. It says cannot assign ID because it is a read-only property. So we cannot assign anything to it because it is a read-only. Now, I want my robots to have a read-only ID as well as a read-only model number. The name I could change, I may change in the future. So that's everything you needed to know about read-only. But what is optional in this context? Well, it is the same thing that we talked about objects. You provide a member or a property, and you're telling the object that that property may or may not have a value. Now, in this context, so far, if I add a durability, and if I say, okay, it has a type of string, I could say string, I could say number, but I'm going to say string since it's easier that way. And as soon as I save it, there is an error because it says has no initializer. Now, I don't want it to have an initializer. I don't want it to have that. I want it to be optional. I want it to be maybe some robots. This is a key factor. For example, for the kind of robot that can lift things. But for another robot that maybe brooms the room, I don't want this to be the factor, the main factor. So it's maybe like something that I want my application to do. Now, in that case, what I would do is I would make it not required. I would make it optional. And we need to add the optional operator or optional modifier. And that is simply question mark. And that's it. The error is gone. And you have noticed that I've put the JavaScript side by side because I needed more real estate for this class. It was a little bit cumbersome, like scrolling up or down. Here is the compiled JavaScript if you want to take a look at that. If you're following along, you're going to see the JavaScript. You can see it by just looking at your code. It's there as well. Now, this durability is the kind of property that we may or may not add. That is up to us. So if I say robot, let's log the robot and take a look at it. ID, model, and name. Where is durability? It is optional. And let's add that robot dot durability, and then I'm going to say hi. I don't know what the actual measurement system is, but I'm just going to say hi. And as soon as I do that, let's actually log. If I take a look at that, here it is. It says durability is high. It has been added. But it is optional. You could add it, you could not add it. You could just choose not to add it. And that's everything you needed to know about read-only and optional properties. Hi everyone, in this video I would like to talk about access modifiers that TypeScript offers us that do not actually exist in JavaScript. With these access modifiers, we can change how class properties are accessed. TypeScript gives us 3 different access modifiers. We have public, private, and protected. I'm going to talk about private and public access modifiers in this video, and I'm going to dedicate a video to protected members later in this chapter. Now, This is the code from our previous lecture. Just to let you know that when I copy the code to the next lecture, I just comment everything out. And if you want to see all the syntax highlighting, you just have to select everything, uncomment everything. But I'm just going to comment it out because in our next lecture, there's not going to be any kind of conflicts. Now, first off, I would like to talk about the public members. The public members of, or the public access modifier says that we can access any property, any member outside the class. As with the durability, we can see that we say robot the durability equals high. So we are accessing it outside the class. That is because when you create a member in a class, by default, it is public. So it is written like this. You could write it like this, or you could just add the public keyword at the start of it and save it. There is nothing changed, nothing. And if I jump over to JavaScript, you can see we don't see that public because public, private, and protected, they're limited to TypeScript. This is what TypeScript offers us for better type safety. So the takeaway so far is that every member, every property, and every method by default is public. That's why we can access it outside. We can access the walk method. We can access the model property, the name property, the durability property. We can access all of them outside because they are public. Now, I'm going to show you an example of private in a second. I'm just going to show you how we can access this ID. So if I say log robot dot, if I take a look at the ID, we can see that it says 1051. Why? Because it is public. Now, if as soon as I change this to private, there is an error. And the error says is the property ID is private and only accessible within class robot. So that is the difference between public and private, and that's how simple it is. Now I'm going to complete this lecture because there is like a couple of things that I would like to talk about as well. Now I'm going to make this ID public so we can access it. And keep in mind, if you add public or if you choose not to add it, there is no difference. But adding it is better, so when you have private members, you should know which are public members. So when you add the private, you need to add public as well. It's like TypeScript infers that, but you need to type annotated anyway because that is a best practice. So I'm going to say this is public as well. And I'm going to add this public to the name and also to the durability. Now, where is the private? I'm going to create another property. And I'm going to say this is a private property. And this is sentient. Whether our robot has become sentient. I'm going to say whether a robot has become sentient. And I'm going to type annotated a Boolean. Cool. I'm going to get rid of the ID and get rid of this durability. We don't need that. I believe we would need this robot right there. So since the sentient has been created and it has not been used, it doesn't have an initializer. We need to add an initializer to it first. So in here, I'm going to say sentient that has a type of Boolean. And then I'm going to say this dot sentient is equal to the sentient parameter. So I'm going to copy the name from there, put it right here. And now everything is cool. It says it is declared, but this value is never read. Now there were two errors, now there is one. The initializer has been created, but we need to pass it. We need to basically give it a value as well. And that is where we provided within the instantiation of the object. That's where we pass in the value for it. Now I'm going to say, okay, our robot has become sentient. And if I save that, this value is never read. I have provided the value for it, and the error from here is gone. And I'm going to use this sentient in a function. So it basically, I want to shut it up, all the errors, so we can move on with our lecture. So I'm going to say ability to think, and I do want to return a Boolean from this function. So Boolean, and I'm going to say return this dot sentient. That's it. Just return this dot sentient. Now that we have done this, let's actually call it within the context of the robot. And we should get an error. Why? Because this property is private. So I'm going to say log robot dot, we do get that ability to think, and as soon as I call that, let's save it, we do get true here because we're calling the function. We are not accessing, keep that in mind, we are calling this function, but we are not directly accessing this sentient property. If we try to access it directly, that's when we are going to get an error. Now in this case, the function is calling it, is getting its value, that's why we can see it true. But we are not actually we are not actually getting the value. So if I say robot dot, we can't even see sentient in there. Why? Because sentient is a private member. We got the ability to think, durability, which is optional, ID, model, name, and walk. Whereas sentient is private. As soon as I convert it to public and do the dot notation, here it is. Here is the sentient. So this is the first hint that you should not access this outside the class. So even if I just become very stubborn and do it, we can see that property sentient is private and only accessible within class robot. So what I could do is just copy this entire thing and put it here for your reference. And that's basically it for this lecture. Now we need to jump back into the JavaScript code so we can take a look at what exactly has changed in our JavaScript code. So if I jump into the JavaScript code, we don't see any private or public modifiers because they are limited to TypeScript. And there is actually one more thing that I would like to talk about, and that is we can use these access modifiers to shorten the class syntax itself. So we can see that we got some redundant code. We have ID here, we have the same ID here, and then we have another ID here. So there are like this one ID has been repeated 2 times here, and then there is a parameter called ID. So instead of having all these right here, what we could do is we could basically go ahead and get rid of all of them. So keep in mind that ID, model, name, durability, they're public. So I'm going to copy the public, put it there, put it in front of model, put it in front of name. Durability is optional, keep that in mind. And sentient is private. But there is something else. We got two properties that are read-only. So ID is read-only and model is read-only as well. Now that we have done that, we no longer need this. So I'm going to remove it. Prettier is going to rearrange everything, and we got the same result. So I just shortened our code by 5 lines. Imagine you have 100 properties, and you will have shortened the code by 100 lines, which is cool. So these access, so if you don't do these access modifiers, like if I get rid of the public and get rid of this one, get rid of this one, get rid of this one, these modifiers are what allows us to not define the property and then initialize it, but define and initialize it within this function declaration, this constructor definition. So you can see that ID and model, they're not throwing an error because they do have an access they do have some sort of a modifier. But name and sentient, they're throwing errors because they don't have any modifier. It says property name does not exist on type robot. So everything is working correctly. Our code is shorter, and we can see everything right here as well. So we got this dot model, this dot ID, model, name, and this. It seems like we have repeated ourselves twice in the JavaScript, but that shouldn't be a problem because we are focused on TypeScript and how we can actually learn to work with TypeScript. So that's it for this lecture. See you in the next one. Hi everyone, let's talk about getters and setters. Getters and setters, they are functions, they are methods that allow us, they're technically accessors that allow us to access the value of private members and also modify those values outside the class. Now there are a couple of changes that I would like to bring into our robot class. This is the same class copied from our previous lecture, public and private members. And in the previous lecture, I briefly brushed over this thing right here where we have duplicate initializations for every single property. And this can be avoided. The reason for this is because whenever we use access modifiers like public, read-only, private, within the definition of the constructor, what happens is that these properties are being created and they're being initialized at the same time. So technically, we don't need these 4 lines of code, and I could just get rid of it and everything would work perfectly fine. And now you can see that duplicate code has gone away. Cool. Let's move on. The next thing that I would like to add is that durability property, and I'm going to make it a public one. It is by default public, but I'm just going to add it there. Durability. And this is optional, so let's add that operator there. The type for this one is going to be string. So far, everything is making sense. Cool. Let's move on and let's talk about getters. So a getter function allows us to get the value of a private member outside the class. Now, before jumping into the getter function, I would like to show you a convention that is being adopted in the TypeScript world. And if you see it somewhere, you would know that this is a private member. Private members are sometimes denoted having an underscore at the start of them. So if you see it anywhere, it's not something unique. It basically says, for example, this dot sentient basically says, this underscore says that this sentient is a private property. There is no other use case to it. Just it is like one level differentiation when you use private members within the class, since they are created to be only used within the class. And now when you see it, like you create the class and like maybe 50 lines later within that class, you use a private member, you want to use that, you immediately know, okay, that they are starting with a underscore. So this is like a convention. And getting back to the getter function, we saw in a previous lecture that through this dot sentient, we were able to access the value of sentient, which was true from here. And what I would like to do is I would like to change the name of this ability to think method to sentient as well. So this is a getter function, keep that in mind. Now changing the name is just going to make things easier for us. It's not like something you have to do for technicality. It's not important. It's just easier to read. And to make any function a getter function, just add the get keyword at the start of it. And now we have access to the sentience value outside the class. How, you might ask? So I'm going to say log. Let's grab robot. Let's do a dot operator. And as soon as and you can see there, we got that sentient. And in case you're wondering, before that, we couldn't see that sentient there. It is like listed as a method. It is not listed as a property. As soon as I add that get accessor there, it is listed as a property. So I'm going to say get sentient, and it's going to be robot.sentient. And as soon as I save it, okay, log dot cons. I actually forgot the first part. And there we go. It says true. Now, what happens if I try to change the value? Will I be able to change it? So I'm going to say false. And as soon as I do that, there is an error. Cannot assign to sentient because it is a read-only property. Now you can see it doesn't say private property. It just says it's a read-only property because it is private. I'm going to get rid of that error. The reason that it doesn't work is that getters just get the value. They don't set the value. If we want to set the value, we need to create a set or a setter function. So a setter function starts with a setter, with a set. Normally these are called setters. So a setter starts with the set keyword. And then keep in mind that it's going to have the same name as the property that we're trying to set the value for. So what is this going to accept, this method? This method is going to accept our sentient property. What is the type of that? The type of that is going to be Boolean. And what do we want this method to return? We don't want this method to return anything. We just want to access the value of it so we can change that. So I'm going to say this dot underscore sentient, which refers to our private property. We are going to set it equal to the sentient parameter. So far, everything is making sense. And now, as soon as I do that, and if I come here, and if I change this, now you can see there is no error. And as soon as I save it, you can see it was true, but now the sentience value is false because we changed it right there. So to sum everything up, with the getter function, we can access the value of a private member outside the class. And with a setter function, we can modify the value of a private member outside the class. Index signatures allow us to dynamically add properties to our objects, which is something that TypeScript does not allow by default. For example, if I were to create an object called robot and set it to an empty set of curly braces, I think I did not comment out the previous lecture's code. Let me just comment this one out so we don't have any kind of errors there. So if I create that and if I try to add properties or members to it using the dot notation, for example, robot, and let's say robot has head, and then try to assign it to I don't know, like a value of Boolean, this is not going to work. Why? Because property has head does not exist on type of this object. You cannot add dynamic data to our object. You cannot add data to objects dynamically because TypeScript is extremely strict when it comes to the shape of an object. Now, the same thing goes for a class as well. But what index signature properties allow us to do is to add dynamic properties to our classes. Now, I'm going to create a class of robot. I'm going to keep it very simple so you can understand what it is that we're talking about. So I have this class of robot. And this class of robot we know is a factory for robot objects. Now, some robots, they might have hands. Some robots might even have legs. Some of them might not even have hands or legs. So it depends on what kind of robot has what kind of properties or features. And what I want to do is I want to choose that on the fly. I want to choose these members and these properties or different features of every robot dynamically. I don't want to have like a fixed system for them. That's where index signatures come into place. Now, for example, if I want to create 10 robots from this robot object, and each robot has a different feature, I need to list all the features right here so I can use it in every robot. And the robot that doesn't have those features, I'm just going to say, okay, it doesn't have those features. And I'm going to end up with a redundant code. For example, let's say I want to create, let's create the constructor. And within the constructor, I'm going to say public. And let's say I want to check whether my robot has head, has basically hands, has hands. And then I'm going to set it to a value of, for simplicity purposes, I'm just going to set them to a value of Boolean. And then let's create another one. And let's say has legs. And I'm going to set it to a value of Boolean as well. Now that I've created that, I want to create two robots from this class. One robot has hands, one robot has legs. But for every instantiation, I need to provide a value for both of them. See, so I'm going to say let robot1 is equal to new robot. And as soon as I do that, you can see it asks me for hands and legs. So I'm going to say true, but this robot doesn't have legs. So I'm going to say false. Now I am forced to write this even though it shouldn't be listed as a property of this robot1. Now this is where we want to create dynamic properties for every individual robot. So how would we do that? That is where index signature properties come into picture. So first off, I'm going to create this pair of square brackets. And in here, what do I want to create? I want to create body parts in a dynamic manner. Now the type of body parts, what is going to be their type? How do we type annotate body parts? So they could be heads, legs, hands, mouth, eyes, like, I don't know, like sensors or wings or whatever. You can see what type do they have all in common? They have a type of string in common. Now, as soon as I do that, now a body part that is of type string must be evaluated to what kind of value? So do you want to assign different IDs to different body parts? For example, head has a value of number 1. I don't know, like eyes or maybe like hands, they have a value of number 2 and then number 3. So do you want them to be numeric or do you want them to be like Boolean values, like true or false? I'm going to keep them as Boolean. I just explained that, so I'm not going to go over it again. And now I'm going to create a robot and I'm going to say let robot1, like I just did before, new robot. And as soon as I do that, you can see it's not asking me for any kind of arguments. Now I'm free to do whatever I want. So let's say our first robot has hands. Now keep in mind, this has hands must be of type string. That's what we have specified right here. It must be of type string. Now if I say .1 is equal to true, this is not going to work. Why? Because it says unexpected keyword or identifier. We have specified here that it has to be of type string. And I'm going to say, and .1 is not actually working anyway. So I'm going to say has hands. And as soon as I save that, now our robot object has a property, as a dynamic property of has hands. And I could just log that, robot1. And as soon as I log it, you can see that we have this has hands. Now, if I log it before that, it's an empty object. Now it has one property. Now, what about the other, come on, buddy, what am I doing? The other robot. So I'm going to say let robot2 is equal to new robot. And now to this robot, I could simply say has legs. So just, I'm going to copy these lines from there, put them here, change 1 to 2. And instead of hands, I'm going to say legs. Save that. Now we got two different robots, two different objects. Oh, this is still robot1, and I have to change it to robot2. And one robot has hands and the other robot has legs. And I don't have to clutter the constructor with a lot of properties that I may not use for all of my objects. So now each object can have any kind of property that they want. But with our previous classes, what we ended up with was that every object must have the shape that that class has. Now the shape of this class is fluid, it's flexible, and so the objects will be flexible as well. This is all about index signature properties. There are occasions when two classes have the same properties and methods, but instead of repeating the code twice, we can leverage inheritance to shorten the code. In this case, the duplicate properties and methods are going to be extracted into a separate class, and then other classes can inherit these properties and methods that they require. Now, let's just jump into the lecture, since inheritance is a very, very important topic in object-oriented programming, and I want you to really understand that. What I'm going to do is I'm going to create a class of robot, and I'm not going to copy paste the code from our previous lectures. I'm just going to create it from scratch. And this class of robot is going to have a constructor. the constructor is going to have several properties. All of them are going to be public. So we are going to have a name that is going to be of type string. We are going to have a model that is going to be of type string as well. Then I'm going to add our durability, which is going to be of type string. And finally, we're going to add the weight, public weight, weight, which is going to be of type number. Let's save everything, and everything is working correctly. Let's add that. There we go. I think index signatures. Why do I keep forgetting to comment these ones out? Get rid of this here as well. Save that. There we go. So everything is working correctly. We should have our classes. We don't have it because we have not instantiated it. So everything is working correctly. Everything is fine. Let me just take a look at the server. Found one error. Index signatures. I just fixed that. Didn't I? I did. Found one error. Class robot. Do we have any other? No, we don't have any other. Index signatures. Let me just Control C. Rerun it. And there we go. Found 0 errors. Cool. Now that we have created this class, now I want to create 2 robot objects. What I could do is I could use all of these info within those 2 robot objects, or I could like repeat myself, or I could just have them inherit those properties and methods. Now I'm going to keep this inheritance lecture simple. We're not going to dive into too much into technicality, but I'm just going to teach you enough so you can understand what inheritance actually is. Now, if I want another class to inherit from this, the way that we can do that is basically use an extends keyword. So I'm going to create another robot class, and the name of the robot is Avden. And I want this robot class to inherit all the properties of the robot class, this Avden robot. So I'm going to say extends the robot class. Now all the properties can be accessed in here. Cool. Now let's go ahead and let's create a constructor for this one. And within the constructor in here, what we could do is we need to specify what kind of properties we want this specific class to have. So I want to have the name, I want to have the model, I want to have the durability, and I want to have the weight from the base class. A quick note on the namings, on the naming convention. The this class from which other classes inherit, this is called the superclass, the base class, or the parent class. And the classes that inherit from this one, they are called the child class, the subclass, or or the derived class. So I want to get the name, the model, the durability, and the weight. And I'm going to add all of them right here. So let's go ahead and let's add them. I'm going to say I want to add an ID as well. That is going to have a type of number for this robot. And I want to get the name. That is going to have a type of string. Keep in mind, I'm not adding those access modifiers because it extends the robot class. Those access modifiers have already been added, and I don't need to add them again. Model and durability. Model is going to be of type string. Durability is going to be of type string. And then what do we have next? We're going to have weight, which is going to be of type number. Let's add the code block for that. Now that we have created this, you can see it says constructors for derived classes must contain a supercall. We are going to get back to the supercall, but first I need to make some adjustments to our robot class. Now this robot for now is sharing all of its properties. It's not doing anything. So I'm going to be adding a very simple method that is going to be a get method or a get function or a getter, and I'm going to say robot data is going to be the name, Now I want to put everything in perspective within here. So I'm going to say this function returns a very long string. The string is going to say this dot name robot model number. Let's add the model number. This dot model has a durability of, let's add the this dot durability, and then I'm going to say and weighs in at the weight, this dot weight. Now I want to use this method without actually writing the method within this Avden class. How can we go ahead and use that? Now we need to make a call to the super class using the super method. And within this call, we need to specify these properties, the name, the model, the durability, the weight, all of these. So I'm going to say name is going to be name, model is going to be model, durability is going to be durability, and finally we have weight is going to be weight. And as soon as I do that, we can see that we have not actually used the ID here. We could go ahead and we could use the ID as well. And I'm not going to pass it right here. I'm just going to keep it for now there. Let's go ahead and let's create another class. And for that, I'm just going to copy this one, put it down here. And I want to have two classes that extend the main class. This class, I'm going to name Weeks. This is the name of the robot. And everything else is going to be the same. So we are passing all this info back into the robot class. Now, if I want to initialize any of these classes, I'm not going to initialize the robot class because the robot class doesn't know what we are actually talking about, because here is a class that extends all of those properties and all of those methods. So I'm going to say let Avden robot be equal to new Avden, Avden, and as soon as I do that, I need to pass in an ID, which I am going to pass. And what should be the ID? So the ID that I'm going to pass in is going to be 11254. The model number, the name is going to be Avden 5000. Cool. And then we need to provide the model, which is going to be AN233. Durability, let's add medium since that is a string. And finally, the weight is going to be 25 kg. And as soon as I do that, we have not used this ID. Let me think where I can use the ID. Where can we use the ID? We should be able to use that. Now, let me just add that access modifier public. And that is going to get rid of that yellow squiggly for us. I'm not going to use it anywhere. The reason that we didn't add modifiers to these is because we have already added them there. This is the Avden robot. I'm going to create an instance of the Weeks robot as well. So it's going to be VEAX robot new Weeks. And the ID number for Weeks is going to be, let me just come up with a random number, 25485. And the name for the robot is going to be VEAXCEL Vixel 5000. Vixel 9000, not 5000. The model number is going to be VX255, I think. The durability is going to be high, and the weight is going to be high as well, like 75 kg. Oh, 2 sevens. Cool. And now we can take a look at these in the console. I'm going to say log Avden robot, save that. There we go. We just created all of that. And we can also take a look at the Weeks robot. Weeks robot, and save it. And here is the Weeks robot. Now everything is okay. Everything is making sense, right? The thing is that there is an issue with our code. And that issue is that so far what we have done is we have created a main class or a parent class, and we have two other classes inherit from this. But this doesn't leave us with the instantiation of, this does leave us with a problem in our code, and that is we can instantiate this robot class. Now, what happens when we create a base class in TypeScript is that whenever we create a base class, that base class on its own is nothing. It doesn't do anything. It is just a place for us to put data, put properties and methods so we can reuse them later in our code. And we should not be able to instantiate that class. Now, so far, if I just go ahead and if I say let robot equal to new robot, we have access to basically that robot. And now we need to, even though in the context of this robot, we don't know what robot it is that we're talking about, because we have created child classes from this. We know that in the first child class, we have the Afton robot. In the second one, we have the Weeks robot. But what robot do we have here? What is the robot name in the context of this parent class? We don't know. What is the robot model? We don't know. What is the durability and the weight? We know nothing about that. Because this serves just as a way for us to reduce code. And that's it. So technically, we should not be able to instantiate that. And that is where the concept of abstract classes come into the picture. And abstract classes basically say that when you have a base class, the base class should not be instantiated on its own because it doesn't make sense. It's not a complete class. We inherit from that, from the base class, or extend it in other classes, which basically complete it. But on its own, it does nothing. It means nothing. So as soon as I add the abstract class, as soon as I add that, and you can see that the error basically changed. So I'm going to get rid of this abstract class, just the abstract keyword. And now as soon as I come here, you can see it says expected 4 arguments, but got 0. An argument for name was not provided. So now it is asking us to provide arguments. But as soon as I change this to an abstract class, it is no longer asking me for arguments. It is telling me that you cannot create an instance of an abstract class. And that is where we typically use abstract keyword in our classes. This is, again, to signify that this is not a complete class. It's an abstract thing that we use in our code. And it's not doing anything on its own. It's nothing on its own. That's just to avoid that bug in our code. We just say, okay, abstract, add it to the main class. So we are never able to instantiate a base class. All right, let's talk about protected members. We have already seen how private and public members work. Any member, when not assigned an access modifier, is public by default. Private members are created by adding the private keyword, and these members cannot be accessed outside the class publicly. However, if we want to access these private members within a subclass of a superclass, it will not work since they are private to the base class only. Let's see that in action. Now, first things first, what I would like to do is I would like to get all these public members, and I'm going to change all of them to private, and let's see what kind of issues arise. Let's save that. Now, as soon as I do that, we should not be able to get the value of the name or the model or the durability or the weight within the child class, within any of the child classes. So what I'm going to do is I'm going to jump, but before doing that, let's just not do that first. Let's just take a look at it publicly. So we have this Afton robot, and as soon as I do the dot, I can get the model. For example, we are going to take into consideration the model. It is AN233. And now let's change all of them to private. And as soon as I do that, you can see that there is an error that says property model is private and only accessible within the class robot. So now it is not accessible within this class. That's why I cannot access it using this instantiation. Now, this is the kind of issue that protected members sought to fix. The issue is whenever we have a base class and we have child classes inheriting properties and methods from the base class, technically we would want those child members to have access to the private members as well. Since they're extending that class, they must have access to all of the members. That's where this keyword of protected or this access modifier is important. It allows us to use that in our child classes. Now, what I'm going to do is I'm going to create a method within the Avden robot. I'm just going to work in here. And I'm going to call this a public method. Methods could be public as well. And then job of this method is to get the model. Model is going to be of type string. And I'm going to say this dot model, I want it to be equal to the model parameter that we have added. And as soon as I do that, you can see we got the same error. It's private and only accessible within the class robot. We can't access that. So what we could do is, we could, instead of saying that all of them are private, let's say we want to access the model class. I'm going to keep the rest of them as private, but I'm going to change this to protected. And as soon as I do that, you can see we have, I'm going to come back to this error. We have access to the model, even though it is protected. But protected members cannot be accessed publicly either. So that is what they have in common. Private members and protected members cannot be accessed publicly. But private members cannot be accessed within a child class. However, protected members can be accessed within a child class. And that is what we would want to do. That is what we would want at the end of the day, to access that. For this example, I could get rid of this, this class. I'm not going to need it, just to make sure the code is shortened. And so I did talk about protected. We did take a look at that. I'm just going to convert it to private one more time so you can really see what is happening. And it says private. It is private and it's only accessible within the base class. But as soon as we change it to protected, that is going to change. We have access to it. And when I call this method, this is going to give me the model number. Even though I can't access it publicly, let's take a look at that. We got the get model, and let me basically call that function. And let me save that, Avden robot.get model. This is going to give me the function. What is happening here? It says model string, an argument for model. Oh, I need to provide an argument for the model. Here is the model. Let me just copy that, put it right here, and save that. And it returns undefined because we're calling the function. It shouldn't return undefined. Avden robot. I'm console logging that. Let me just get rid of this. It shouldn't do anything because we are not saying. Let's return this from the function, and that is going to fix the issue. We are not returning anything from the function. Let's save that, and there we go, AN233. Otherwise, we are not going to have access to it. So if I convert this back to private, you can see we immediately got an error. Found one error. I'm going to get rid of this. It says model is private and only accessible within the robot class. But I'm going to convert it to protected. Protected. And now it is accessible and we can see it on the console. So to sum everything up, protected members are private members that can be accessed within a child class when it extends a base class. And protected members, just like private members, cannot be accessed or modified outside the base class or the child classes. You can't just get them from the base class publicly or from the child class publicly. It doesn't work like that. That's it for this video. See you in the next one. we already know that interfaces provide the shape for an object. And whenever we try to define an object using an interface, it allows us to have a little bit more type safety. We can have the same feature for classes as well, because at the end of the day, classes are objects as well. We can define the shape of a class using an interface. The only restrictions will be that within the interface, we can't add a property that is either that is either protected or private. And we cannot have getter or setter within an interface. Other than that, there is basically nothing limiting us. So first off, we are going to create our interface, and I'm going to call this the robot interface. And what I'm going to do is I'm going to add the name that is going to be of type string. I'm going to add the model, even though the model is protected, but we are going to come back to the error later. It's going to be of type string. And then I'm going to have durability. So far, there is no link between the interface and the class. We are going to provide that link, don't worry. And then the weight is going to be of type number. Now, the way that a class has an interface is that the class is going to implement the interface. And we have the implements keyword, and then we are going to add that interface. And as soon as we do that, there is an error. And that says that is basically talking about the model property, which is protected in the constructor of the class, but it is public right here in the interface. So we need to get rid of that. That is the first issue. The second thing is that we have not added this getter function, and I'm going to just add that robot data. And I know this robot data is going to return a string. And as soon as I do that, there is another error that basically says that this property has the same name as the one that is here. That is because it doesn't know what it's talking about. What happens here is that since this is a method and we have added get, it is no longer a method. It is a getter accessor or a get accessor. And we need to get rid of that get. And as soon as I save it, there is no error anywhere in sight. And everything is making sense. Now, if I were to add anything to the interface, for example, if I were to add sentient, which is equal to Boolean, and I save that, we are going to see that it says class robot incorrectly implements interface robot interface. And that the property is missing, the sentient, and we need to add it there. So that's a good type checking for us. Very cool. Now, this is the interface for this class. I'm going to create an interface for the first child class, and we are going to have an interface for the second child class. For this one, I'm going to say interface Avden robot. Avden robot is going to have an ID of number. It is going to have a model of, come on, buddy, ID of number. It's going to have a model of string. I know, I'm going to come back to that. Durability is going to be string. Weight is going to be number. And then it also has a method that is called getModel. GetModel that returns a string. And now let's say that this Avden robot implements the Avden interface. So I should just change this to interface. So this is like robot interface, Avden interface, and like that. So implements Avden interface. And as soon as I do that, there is an issue there that says getModel is not assignable to same property with the base type. And we have ID, name, model, durability. Let me get rid of this model. Okay, this is returning string for us. Type model string is not assignable to type string. I did not add the, I'm going to uncomment that one. I did not add this property. So I'm going to say it is going to accept the parameter, which is going to be of type string. And now the issue is gone. Cool. And says, now says Avden incorrectly implements interface after an interface. Property model is protected, but it is public in this interface. So we need to get rid of that, and everything is working perfectly fine. And I'm going to copy this interface, and I'm going to do the same thing for the weeks. It just gives us a little bit more type safety. So we have ID, name, model, durability, and weight, and we don't have anything else. I'm going to change the interface name to weeks and implements weeks interface. And we don't have any errors. We got our code, we got that object in the console, which I'm just going to get rid of, and everything is working fine. That's it for this lecture. See you in the next one. Hi everyone, in this lecture we are going to talk about the static properties and static methods. A static member is the kind of member that only exists on the class. It cannot be accessed in the object instantiation of the class. And for this reason, we do not really need to create an instance of our class. For example, let's say we have a class that is of product. And this class has only one member, that is holiday sale. And this member's type is Boolean, and I'm not going to create a constructor, therefore I need to initialize it right here, and I'm going to initialize it to a value of true. Everything is cool so far. Now, I'm not going to add the static keyword, but first we are going to explore something else. So if I create an instance of this class called lowercase product, then I would have to say product, and now this basically created an instance of, where have I declared this lexical scope? Let me just get rid of it there and comment everything out. There we go. So let me just close that. Now we have created this class right here, and we have instantiated it right here. So this is an instance, this product is an instance of the product class. Now, if I were to say log product dot, we can see that we have access to its member. But there is a very cool thing happening here, and that cool thing is that this holiday sale is not accessible on the class itself. It is accessible on the instance of the class. Now, what if you want to access this holiday sale for some reason on the class itself? That is when we are going to use the static keyword. So what I'm going to do is I'm going to add a static keyword to the start of this member, and as soon as we do that, there is an error, and it says property holiday sale does not exist on type product. Did you mean to access the static member product? And it even gives you a solution. So you can see that this is a uppercase P. And now we no longer need this instantiation, and we can basically access that on the product class itself. And as soon as I save it, we get that true there. And now what I'm going to do is I'm going to show you how you can create a static method as well. Let's say we want to create a discount method, and depending on the season, we want to return a string from this method. And the string is going to say if product dot holiday sale. If product dot holiday sale, if this is true, what do I want to do? I want to return a string. The string is going to say biggest, is that correct? Biggest sale of the season. If this is not true, then what do I want to do then? If this is not true, I basically want to return 25% off. 25% off. Let's save that. And let's actually take a look at that in the console. So we need to go ahead and invoke this function. I'm going to enlarge the console a little bit so we can really see what is happening there. So we got product.holiday sale. I'm not going to do anything to that. I'm just going to say product dot, and now we have this holiday sale, and we must also have the discount. But the reason that we don't see it right here is because we have not made it static. So let's add the static keyword there. And now if I do the dot operator again, you can see that we got that discount, and it is purple because it's a method. And as soon as I do that, we need to invoke it as well and just save that. You can see it says biggest sale of the season. Why? Because we have initialized the holiday sale as true. If I change it to false, it's just going to straight up say 25% off. And this is everything you need to know about static properties and methods. Hi everyone, let's talk about generic classes. We have seen a lot of examples of generics. We have talked about generic functions, objects, generic interfaces. So generics are not a new concept to you. And the same concept that we have been talking about so far applies on classes as well. Generic classes can accept multiple types as data. Let's say we have a class of product. I believe I have not commented out the previous lecture, so let me just, come on buddy, comment everything out. And I need to uncomment this one level. Let's save that. There we go. Very cool. So let's say we have this class of product, and for some reason we want to work with multiple data types in this class. So what I'm going to do is I'm going to specify a type of T1 and a type of T2. Now in here, what I'm going to do is I'm going to create a constructor, and the constructor is going to have a property or a member called name. Now the name is going to be of type T1. And we need to capitalize T1 as well. And then I'm going to create another one that is going to be public price, which is going to be of type T2. Now, as far as the name is concerned, everything is working perfectly fine, because we know that the name of the product is going to be a string all the times. But the reason that I've specified T2 for the price is because sometimes the price is just like a number and like a numeric form. Sometimes we append the dollar sign to it, or the whatever the currency is, that currency sign to it or symbol to it, and then that becomes a string. So if we want to make this class more dynamic, it would be better to use a generic type. So I'm going to keep this right here, and I'm going to basically duplicate it down below, and I'm going to keep the generic right there, and I'm going to uncomment this one, and we are going to first take a look at the problem. So I'm going to say that the name is of, the name is of type string, and the price is of type number. Now you can see we are hard coding the types. Let's say we have a product one, so product one, and we say new product, and as soon as I do that, it asks me for a name, and I'm going to say TS Bootcamp. And it also asks me for a price. Keep in mind, the type is number. I'm going to say $11.99, for example. Now, what if I create another product? That is going to be product 2. And in that case, it's going to be JS Bootcamp. But I don't want to say $11.99. I want to say $11.99. I want to specify the type, the dollar sign as well. As soon as I do that, and it says cannot find name this, because this is a string, so I'm going to wrap it in quotes. And as soon as I do that, it says argument of type string is not assignable to parameter of type number. So this argument of type string is not assignable to the parameter of type number. Why? Because it says number, this is string. This is where our generic class comes into the picture. And for this reason, I'm just going to bring it up, and we're going to take a look at the solution for that. Now, as soon as I do that, everything is working correctly. But the issue is, let us take a look at our products as well. So product 1, and just down below, and I'm going to say product 2. Let me just bring this over here a little so we can see. Here we have product 1, and here we have product 2. Now the reason that it works is that TypeScript infers the type. As I create this instantiation of the product class, TypeScript infers the type of T1 as string and the type of T2 as number. And for the second product, it infers both of the types as strings. We should be able to see them here as well. You can see it's a string and number. But TypeScript's inference is good enough, but it's also a good idea to actually type annotate these classes. So how would you type annotate a class is exactly like how we would type annotate a function. So within the function definition, the function name, we type annotated there. And then when we call the function, we type annotated there as well. So it's going to be right here. Now, TS Bootcamp is of type string, and the price is of type number. Usually, you're going to do this first, and then you're going to specify that. So your values are type safe. They're type checked against the types that you have provided. But I'm going in reverse because I'm explaining it. Now, in this case, both of them are strings. That's why I'm just going to say string and string. And then it works perfectly fine. So normally what you would do is you're going to say const product 3 is going to be equal to new product, which is going to be of type string. And if I do Boolean, I'm going to do string as well. So it's going to have string and string. And this is going to be Tailwind Bootcamp. And for that, I'm just going to say not available. The price is not available. And let's save that. And we can take a look at that in the console as well. We should be able to see that. Just make this smaller, make this bigger so everything is on one line. Come on, buddy. Oh, it's been formatted. That is why it's not on one line. Cool. We got, save that, product TS Bootcamp, JS Bootcamp, Tailwind Bootcamp. The reason that it doesn't have a price is because it doesn't have a price currently. So this is how you would go about doing it. First, you're going to type annotate it, and then you're going to abide by that type annotation. That's it for generic classes. See you in the next one.
I hope you're ready, because we are going to talk about some of the most difficult challenges of this course. Welcome to part 9 of Let's Get You Coding Challenges. I'm sure it was a fun ride so far when we talked about some concepts and immediately we put them into practice. We did some exercises for them. And in this section, we're going to have a lot of exercises in which we're going to talk about classes, we're going to talk about interfaces, we're going to talk about discriminated unions, and a lot of really, really advanced and high-level stuff. So let's get started.
Hi everyone, welcome to the first challenge. The challenge statement reads, what will the following function invocation print? So let's go over the challenge first, and then we are going to jump into the solution. In here we have a type of department where there is just one property with the type string. Then we have another type that is product. We have a name property and a string type for that property. Within the product info, we are intersecting these two types, and then we are calling a function, which is going to get us the product info. The function is going to accept that intersection type, and it's going to return a string. So far everything is clear. Now, whenever we say that the function's parameter type is a specific type, or an object shape, we need to pass in an object as well. So the object that we pass into the function is this one. There is a department and there is a name. Since we have an intersection, both of the properties are required. So any object created from product info must include department and name. We know that so far. Now here what we are actually using is the destructuring expression or operator, where we are actually calling this object, we are getting it right here, and we are destructuring the department property from the object. And then we return that. So if we do a console log, and if we take a look at in the console, we're going to see the string electronics. Let's go ahead and let's take a look at that. And what I'm going to do is I'm going to copy everything. Let's just put it inside the index.html. I'm just going to put it there. Script, that is going to be challenge-1.js. And as soon as I save it, there we go, we got electronics. So the solution for this challenge is electronics. I'm just going to copy that, comment it out, put it there, and then I'm going to put it in quotes. That's it for this challenge. See you in the next one. The second challenge statement says, what value will the products array log? So we're interested in the products array. First, let's take a look at the code. We have here is our products array, which indicates by its type that it can accept an array of strings. We have hat, jeans, and jacket. All of them are strings. But then we assign this array to a mixed stuff, and we push on a number. Now this is okay, these two lines, because the mixed stuff, this array's type is number and string, so it could accept both of them. But what would happen if we log to the console the value of this products array? What do you think is going to happen? Well, the answer might surprise you, but we are going to see the number 13 being added to this array. It has been added right here. There we go. And the reason for this is because this is the actual technical term is called soundness. This is an unsound system. What it means is that there are some situations where when you're working with TypeScript, the TypeScript might allow something like this, where we have an array of strings and then you are going to provide a number there. And it might get you thinking, like, if TypeScript allows the very thing, the very violation, the very error for which TypeScript was created to remove, when it allows it, then what is the point in actually using TypeScript? Well, you have to think about this. The TypeScript, like many other statically typed languages, it is not perfect. TypeScript is created on the notion and on the basis of working with tons and tons of JavaScript lines of code and packages and libraries and all of the buggy and quirky side of JavaScript. So that's why it has made some sort of a trade-off where it cannot type check our system all the times, because that would result in a major performance drop. So there are these kind of violations that are basically allowed by TypeScript. And if you're even thinking about this, that what if the strict mode is true? The strict mode is true. It is on. And even though it is on, we can see that within our strings array, we in fact have a number. Just keep in mind that with every tool that you use, there are some benefits, and again, there are some disadvantages. And this is one of those that you need to keep in mind and you need to be aware of. The TypeScript, even though it is a very powerful statically typed language, it is not a perfect language. And it acts exactly like any other statically typed language like Java or any other. The third challenge statement says that we need to create a function that returns the length of a string array, or undefined if the argument is undefined. So let's just think about it. We need to create a function that basically returns two different things. It returns either a length of a string array, which means a number, or undefined, which means undefined. Now, it can accept, based on what we have read here, it can either accept undefined, since it's returning undefined, and you can see that it's saying it here that if the argument is undefined, so we can pass in undefined within the function, and it can also accept an array of strings. So it can return two things and it can accept only two things. Let's go ahead and let's create the function. I'm going to call this function myfunc, and I'm writing the solution within the solution file just from the start. And I'm going to name this argument just arg, the argument could be an array of strings or it could be undefined. So far everything is okay. Let's move on. Now, it can either return this length of this array, which is a number, let's write it, or it can return undefined. Very cool. All right, now that everything is okay, let's just think about how we are going to solve this. Now, we need to first check if the argument that has been passed has a type of undefined. Or we could check if it has a type of string. You could go about it both ways, but what I'm going to do is, since undefined is easier to handle, I'm just going to say if arg is equal to undefined, if undefined is passed, then what it means, what do we want to do? We want to return undefined. That's what the challenge statement says. It returns the length of an array of a string array or undefined if the argument is undefined. So if the argument is undefined, it is returning undefined. Else, what does else mean? So we have only two conditions. We have only two different types for the argument. It could either be undefined, which we handled, or an array of strings. If it is an array of strings, we just want to return arg.length. There we go. Everything is okay. Let's test it out. Log. I'm going to get my func, and I'm going to pass in, let's pass in undefined. Let's see how it is going to handle that. There we go. It has returned undefined. I'm going to keep that there. Now, what I'm going to do is I'm going to pass in an array of strings. So hi, hey. This is going to be hey. Come on, buddy. Hey. And then what else? Let's do hello. And also do there. And now, if I save that, what are we going to see? We're going to see the length of this array or a number. There we go. And it is 4. So this is the solution, but what I'm going to do is I'm not going to stop here. I'm going to give you a shorter version. This is like a longer version. We have already talked about operators, nullish coalescing, and within that nullish coalescing operators lesson, I gave you a review of other operators that JavaScript and TypeScript have. And what I'm going to do is I'm going to give you this solution just in one line using the logical AND operator. So I'm going to keep everything commented out there, and I'm going to say, now let's refresh our memory. Now the logical AND operator, it returns the first falsy value that it finds. If both the values are truthy, then it returns the second value. Now what are falsy values? I've already given you the list. Undefined is a falsy value. So I could very well say return arg and arg.length. What this means? What does this mean? It means that if arg is undefined, it is just going to return that. It's not going to return anything on the right side of it. But if arg is defined, it is an array, then it's not going to return that array. In that case, arg is going to be truthy. So it's going to take a look at the other one. And then array arg.length is also going to be truthy. So it is going to return the right side. I'm just going to go over this one more time. AND operator returns the first falsy value that it finds. Undefined is falsy. So if argument is undefined, it's just going to return that. But if argument is an array of strings, then it is not undefined. It is actually truthy. So when it is truthy, then when the left side is going to be true, then the AND operator is going to take a look at the right side, and it's going to see that the right side returns basically a number, like 4, which is true. Therefore, it is going to find that both sides are truthy. And what was the condition if both sides were truthy? It is going to return the second value. What is the second value? The second value is arg.length. So we are going to get undefined from the left side, since it's falsy, and we are going to get the length of the array from the right side, since that is truthy. Let's save that, and we get the same effect, the same result. That's it. See you in the next challenge. Hi and welcome to the fourth challenge solution. The challenge statement reads that we need to create a function that can accept either a number or undefined. So it can accept two things, number and undefined. Cool. If a number is passed, it has to return the number. Otherwise, it has to return 1. So in what scenario it is going to return 1? When undefined is passed. Because if number is passed, we just return that number. But if undefined is passed, we return 1. Otherwise, it's just going to be undefined. That's it. So let's go ahead and let's solve this. But first, I need to change this number to 4 so we can see the changes being reflected. Cool. I'm going to create this function. It's going to be a lot similar to the previous challenges solution. And I did say that we actually studied that in our previous section. No, we studied that like a while back, knowledge coalescing. I'm just giving you some challenges that basically they are going to make sure that you retain the knowledge and you have like some reviews from the code that like several sections back when you worked on, and you actually retain something and you memorize something and learn something, and now you have the chance to practice them. So let's go ahead and let's actually jump into the solution. The function can accept an argument of type number or undefined. So far everything is cool. I keep mistyping undefined. And then it returns 1 or it returns the number that we pass in. So in both cases, it returns a number. Cool. How are we going to check? Again, let's go ahead and let's check for if argument is undefined. If argument is undefined, then what does that mean? It means that we should return 1 from the function. That is 1. And else, within the else clause, there is only one other possibility. There is just one. And that is when we pass in a number. And in that case, we are just going to say return arg. And if I do a dot notation on it, you can see that we only get these number methods, because at this point, TypeScript knows that this in fact is a number. That's it. Let's check it let's check it as well so we can see it works. My func. I'm going to pass in a number like number 10, and I'm going to save it. And you can see it returns the number. But if I pass in undefined and save that, it's going to return 1 for us. Now, the same with our previous challenge, there is actually a shorter version for this one as well. And that is using the logical OR operator. And we talked about the logical OR operator in the knowledge coalescing lecture, which was in the previous section, which was like a few sections back, digging deeper into built-in TypeScript types. Now, let's think about how are we going to shorten this. Now, the logical OR operator, what it does is it looks for the first truthy value. So what value is truthy here? What value is falsy here? You need to keep that in mind. So undefined in this context or in any other context is falsy. So what I could do is I could say return argument if that is undefined. Cool. So this is going to be undefined. If it is not undefined, or you know what, I'm just going to re-explain this because I think I explained it in reverse. So what we are going to do is, since the logical OR operator, it looks for a truthy value. What is a truthy value? A truthy value is a number, not 0 like 1, 2, 3, whatever. That is going to be a truthy value. And when it finds that truthy value, it is going to return it. So I'm going to say return this. But what happens if we pass in a value that is not truthy? What value can we pass in here that is not truthy that this function can accept? Correct, that is undefined. So I'm going to say either return that number, which is truthy, or return undefined. Do we want to return undefined from the number? No. When undefined is passed, we want to return 1 from the number. That's it. So you can see that return 1 and return arg, both of them have been shortened to one line. I'm going to go over this once. If the argument is undefined, it is not going to be evaluated in this context. It's going to be evaluated in this context because the logical OR operator says that I'm looking for the first truthy value. And when we pass an undefined in here, then this is no longer truthy. This is undefined. Cool. Then it has to go to the other side and it finds 1 and it is going to return it because that is the truthy value. Now what happens if both values are falsy? If both values are falsy, it is going to return the right side. It is going to return that. It'll return the second value. So if I just save this, we should not see any changes in our code. Cool? So everything is okay. We are done with this challenge. See you in the next one. Hi and welcome to the fifth challenge solution. The challenge statement reads, what value will the status property lock? Before jumping into the status property, and the reason that I've actually commented this one out is because there is an error and I don't want to show it to you, but because I want to talk about it first. We have a type of user1. You need to be very attentive because this is in fact a topic that we have not explicitly studied, but you should be able how to handle these kind of topics because not all the corner cases that you're going to face in real world will be covered in any single course online. So there are going to be a lot of situations, thousands of situations where you have not studied and where you have not seen anyone solve, and you need to think outside the box and you need to think and you need to understand how you're going to come up with the solution for that. This topic we have not studied. It is called a discriminated union, and I'm going to explain it right here. But I do expect you to really understand that, to really come up with the solution, because I know you can. So let's go ahead and let's see what we have here. We have a type of user1, very simple. We have a property online, type of true. Keep in mind, this is no longer a Boolean. This is a type true. Then the status, which is a string. We have a type user2, online is false. And then we are combining these two types using a union type into a user type. Then we create an object type annotated to the user, and then we say online and status. Now pay very close attention to this. What is the value of the online? The value of online is false. Now, based on this type, union type, which type actually has the online property with a value or with a type of false? That is the user2. So when we are actually using user2 here, does user2 include a property of status? No, it doesn't. That is why it is called a discriminated union, because it discriminates against the types based on which or according to which it is supposed to work. So a union is basically like putting two things together. But in this case, this specific union is discriminating against user2. Why? Because as soon as it sees this online is false, it knows that for user1, online is true. So we are talking about user2. And it is not an intersection type. So we are talking about user2. When we talk about user2, why has this guy or this person said that there is a status property? Clearly, there is no status property. So I'm going to discriminate against that, and I'm going to throw an error. And the error is going to say property status does not exist on type user, and then it doesn't exist on type user2. Let's hover on it. There we go. So it says type online false status string is not assignable to type user. Why? What is the reason for that? Object literal may only specify known properties, and status does not exist in type user2. And if I take a look at it here in the log, if I hover on it, there we go. Property status does not exist on type user, and property status does not exist on type user2. Now, if we were to change this to true, then everything would work out, and we would see a complete object, something cool. Status, something cool. But since it is false, it already jumps into here and it sees there is no status, and that's why it throws an error. It says like it's basically incompatible. And that is the solution. This is the solution. Property status does not exist on type user, and it also does not exist on type user2. See you in the next challenge. Hi and welcome to the 6th challenge solution. The challenge statement reads, what will the online course object log? First, let's take a look at our code, and I'm just going to jump into console. So we have an interface of product. There is a name property with a type of string. We have an interface of, again, another product, and we know that this is allowed, and this is called declaration merging or merging interfaces. So this is allowed in TypeScript. Cool, everything is cool. And we have already talked about some edge cases that might arise from doing something like this. But in here, in this very specific example, and very small and simple example, we have two interfaces with the same name, but their properties are different. One is name and the other one is published. So what TypeScript will do is it will merge these interfaces together, and when we create an object, that object is going to have a property of name, tsbootcamp, and is published true. So technically, if we call this object, if we try to log the value, we should see name tsbootcamp and is published true. So let's save this and let's take a look at that. There we go. That is it for this challenge. Hi and welcome to the 7th challenge solution. The challenge statement reads that we need to create a product class with two properties, name and number of students. Then we need to add a method to this class that will return the string bestseller if a course has equal to or more than 3,000 students. So we need to create a class with two properties, name and number of students. So far it's good and simple. Then we need to add a method that would return the string bestseller if a course has equal to or more than 3,000 students. Otherwise, it should print not so much. All right, let's jump into the solution. I'm going to create a class, and the class is going to be product, since it's requiring us to do that. Then we are going to have a name with a type of string, and number of students with a type of number. After doing that, we need to initialize these as well within the constructor. Name is going to be string, and number of students is of type number. And I'm going to say this dot name is equal to name. This dot number of students is equal to number of students. So everything is cool. So far, one part of the challenge is done, the easier part. The more difficult part is coming up with that function. I'm going to call this method bestseller. And I'm going to say that this method, it returns a string, right? In both cases, it returns a string. The string could be bestseller or not so much. Now, I'm going to say return. What do I want to calculate? I want to calculate the number of students. So I'm going to say this dot number of students. If this dot number of students is greater than, or what did it say? It says more equal has equal to or more than, so there is like an equality sign there as well. 3,000, then I want to return the string bestseller. Otherwise, I'm going to say not so much. I think that's it. We are done with this. Let's create a couple of instances from this class. I'm just going to give this a little bit more space. So there is everything is on one line, nice and easy. I'm going to say const flex course new product. What does it require us? It's going to require us to provide in a name. I'm going to say flex box course, and then it is not actually a Flexbox course, it's Flexbox Grid and SAS course. And the number of students is for 200, for example. And then I'm going to create another object, and that is going to be Python course. Python course. And let's just add it here as well. That is going to be Python. Number of students, 1300. Now, in the case of Flexbox course, it has to return this method for us, bestseller. And in the case of Python course, it should return not so much, since it doesn't satisfy this condition. And we know what this is. You know that. This is a ternary operator, very simple stuff. I'm going to say Flexbox, come on, buddy. Flex course dot, let's get the method, and let's invoke that, and let's save it. And there we go. It returns bestseller. Very well. And now let's go ahead and let's call in the Python course. And as soon as I save that, it's not going to say bestseller. It's going to say not so much. That is it for this challenge's solution. See you in the next one. Hi, and welcome to the 8th challenge solution. And the challenge statement says that we need to write a function that sets the price of a course and takes either a number or undefined. Everything is cool. The argument could be a number or undefined. If undefined is passed, it returns a price of 9.99. Otherwise, which specifically means a number is passed, it returns the given price. Cool. Let's jump in. And in this one, we're going to use nullish coalescing as well. Since we're dealing with undefined, we could use that as well. I'm going to create a function that is going to be, I could just say my func. Since this is in continuation of the previous couple of challenges where we talked about the and the or. The argument in this scenario, it's going to be a price. And I could just name this get course or set course price, not get it, but set it. And then we need to pass in a number or undefined. These are the only things that we can pass in. But at the end of the day, we are just going to get number. If undefined is passed, we set a number of 9.99, a price, a fixed price. But if a price is passed, we just return that. So let's fix this. Let's solve that. Now, first, let's check for undefined, since that is easy. If price is undefined, just return 9.99. Otherwise, return the price that has been added, that has been passed. That's it. That is the solution. There is a shorter version using nullish coalescing, and I'm going to do that as well. Let's take a look at the console, set course price. I'm going to set it as 10.99, and as soon as I save it, we are going to see 10.99. Now, what happens if I pass an undefined? We're going to see that fixed price of 9.99. Now, what is the shorter version? Let's first think about it, how we can shorten this. Now, we are saying that if undefined is passed, we want to return the other value. So we are strictly dealing with these two parts. With these three. So if the price is undefined, we want to pass in the right side. But if the price is defined, we just want to return that. What does nullish coalescing operator do? It returns the left side as long as the left side is not null or undefined. If the left side is undefined, which in this case it is, then it just returns the right side. So I can just get this part, copy it, come down here, put it there. I'm going to add another question mark for the nullish coalescing, and I'm going to say return this. This is basically the same thing. Now, we need to remove this undefined, and you can see that there is an issue. Price is declared, but this value is never read. Now, we don't want to pass an undefined here. We want to pass in our parameter. If the parameter is, I'm going to clear the console. If the parameter is undefined, then the nullish coalescing operator automatically returns the right side, which is exactly what we want. But if the price is defined, it is just going to return that. And it doesn't matter what on the right side is. It does not matter. The nullish coalescing operator always returns the left side as long as it is not null or undefined. If it is null or undefined, it returns the right side. So if I just save it, we should get the same result. And there we go. See you in the next challenge. Hi and welcome to the 9th challenge solution. This statement for this challenge reads, what will the following function invocations result in? Let's take a look at the function first. It seems to be a very simple function that adds something. We have two different parameters. One is price, that is of type number, and the other one is sales, that is also of type number. But there is this question mark which signifies that the sales is actually an optional parameter, which we have talked about before. Now, the optional parameter is the kind of parameter that we could define or not define. So if you pass in, then that's cool. If you don't pass in, there is not going to be any kind of error. And then what do we return from this function? From this function, we return price times sales. And then there is that nullish coalescing operator, and then we have 1. So let's take a look at this. What do we have here? We have sales and 1. Okay. So if sales is defined, it means that the user has passed in the sales, then that sales will come out of this pair of parentheses, and that number will be multiplied by price. Cool. So far everything's cool. So let's save this. I'm going to comment out the second console log. So for the first console log, the sales is actually known. It has been provided. So it comes right here. Then it comes right here. Since nullish coalescing operator always returns the left side, unless it is null or undefined, and in this case it clearly is 4, which is not null or undefined, neither undefined, then 4 is going to come out of this parentheses, and 4 is going to be multiplied by the price, which is 9.99. And what do we get with that? 36.99. So everything is cool so far. But what about the second function invocation? In the second function invocation, we do have a price of 10.99, but the price is not known. It is undefined. And when undefined comes in here, the nullish coalescing operator immediately jumps to the right side, and it returns the right side. The right side is 1, so 1 is gonna come out of this pair of parentheses, and 1 will be multiplied by the price, which is 10.99. 1 times 10.99 is going to be 10.99. The 10th challenge statement says that what will the function invocation result in? And this seems like a big challenge, but it is actually very small. Let's go ahead and let's take a look at this. Here we have a type that is succeeded API call. There is a response with the type of success and a value which is of type number. Then we also have another type which is failed API call. Cool. There is a property of response with a type of failure and a reason that has a type of string. We're combining these two types using a union operator into the API call, and we are using this API call to type annotate the return from this function. So the return, whatever returns from the function, has to conform with this API call type. Cool. Now let's take a look at the function. I could zoom this in so you can really see which parts we are talking about. Within the function, we are creating a variable called n, type annotating it to a number. And then we have this s, which is the parameter of this function, and the parameter of the function can only be one thing. So the function produces an API call object, but it can only accept a string. All right? And first I'm going to tell you what the function does, then I'm going to tell you, okay, how it is going to all fit together. So we create a variable here with type number, and then we grab our parameter and put it there. So this number method, what it does is it actually an object that represents a number of any kind. And then it is going to go ahead and it's going to convert it to a number. Now, if we pass in some sort of a string that isn't a number, that cannot be converted into a number, this is going to return NaN. And then we check for that. So if number dot is NaN, if it is NaN, then which object do we want to return? You can see that we have to return an object. Why? Because that is the return type from the function. So in here, within the if statement, we are returning this object. It's going to be response failure. Why? Because a string which we couldn't convert to a number, which was not convertible to a number. And then within the else is going to be the only other case, and that is going to be a string that can be converted into a number. And in that case, we return this object. We return response success, and then the value, which is of type number. There we go. You can see it says value n. So what do you think? If I pass in hey, is hey convertible to a number? Could it be converted to a number? No, it cannot be converted to a number. Therefore, what I'm going to do is, what this function will do is, it's going to return this object. So let's save that. Let's take a look at it in the console. There we go. So it says response failure, and the reason is string cannot be converted to into a number. All right, very cool. But what if we pass in a string that can be converted into a number? So a string of 10 can be converted into a number. That's when it's going to come into the else's block, and then we are going to say response success, and then we are going to return that value. Let's save that. There we go. So response success value is going to be 10. That's it for this challenge. See you in the next one. Hi and welcome to the 11th challenge solution. The challenge statement reads, what will the function invocation result in? We have the same function, but let's take a look at the invocation. In the invocation, we have API call status, and we have passed in number 10, and then we want to grab the value from there. And now, what we're going to do is we're going to take a look at what is going to happen in here. So I'm not going to go over this. I could just go over it very quickly. We have type succeeded API call, response property, and a value property. But on type failed API call, we don't have a response. We don't have a value. We have a reason there. All right. And now we have the same function, which basically checks if the string can be converted into a number, or if it cannot be converted into a number. Then based on that, it is going to give us an object that has to conform with this API call's shape. It has to conform with that. Otherwise, there is going to be an error. So let's go ahead and let's take a look at this. So what I'm going to do first is, I'm going to console log I'm going to invoke the function here, but I'm not going to get the value from there. So as soon as we do that, what do you think is going to happen? Since this is, I think I've forgotten, yeah, I have done that. Since this is a string that can be converted into a number, we're going to return this from the function. But what do you think if we want to get the value from this API call status? Let's just log that in, and there we go, there is an error. Why? Because this value does not exist on API call. Property value does not exist on type failed API call. And you can see that, and that's exactly what I meant. So when it takes a look at, when we are using union types, when it takes a look at this failed API call, it sees that even though we have it right here, we don't have it right here. And why do you think this actually matters? Because we're using union type within the API for the API call. Now, if I were to change this to a succeeded API call, then there is going to be another error that says this response is actually not present. This failure is not assignable to type success. Perhaps I could change it to success too. And then you can see there is a reason that is incorrect. So there is like a whole slew of issues when you're using these kind of discriminated unions. All right. So even though this taps into the succeeded API call, we're using a discriminated union. And keep in mind, the return type from the function is the API call. And within the API call, we have the failed API call, which doesn't have the property value. That's why it throws this error. So the solution for this challenge is these two lines. Property value does not exist on type API call because property value, there is no because, but that's what I'm saying. Property value does not exist on type failed API call. That's why it doesn't exist on API call. That's it for this challenge. See you in the next one. Hi and welcome to challenge number 12. The statement for this challenge reads, what will the console log? If we take a look at our challenge, this is the same challenge that we've been working with. For example, we've had that in our challenge number 11. This is the same challenge. The only difference is that when we call the function right here, we pass in a string that can be parsed into a number. Now, when we get a success response, we make sure that we get the value from that success response. I believe it was the previous challenge, let me just open that up, where we wanted to get the value of the success and we ended up with a type error. With an error which basically said that this value cannot be retrieved. And what we have here is that when we say that when we call this API call status function, we basically take a look at what is the argument that we pass in. It is of type string. We can only pass in string. But can that string be parsed into a number? If so, then give me the value for that. That is basically what we do here within the console log. We say that if the API call result.response, what is this API call that result? This is the function invocation that we have stored in. If the response of this is equal to success, that means we are talking about this type. When we talk about that type, it means that we are narrowing the type really, really well. And we just get the value from that. There we go, using a ternary operator. Otherwise, we return undefined. Now, if I take a look at the function call, we pass in a string that can be parsed into a number. Therefore, we should just get the value, which is going to be a number 10. So I'm just going to go ahead and I'm going to save it. And there we go. In the console, we got the number 10. Hi and welcome to challenge number 13. The challenge statement reads that we need to create a product class with a name property and a holiday sales method. So I'm just going to jump in and I'm going to create that, a product class. We are going to pass in a name property, and let's just initialize that as well. Name of type string, and I'm going to say this dot name is going to be equal to name. So everything is cool so far. And then we need to create a holiday sales method. And then we need to create an interface called product info that extends the class. And then finally, we need to create an object from the interface and log the object. So let's go ahead and let's create first the method, holiday sales, and then I'm just gonna return true from this. I'm not gonna do, since I have not actually specified what I'm gonna do with that, I'm just gonna return true from it. Let's go ahead and let's create an interface that extends the product class. I'm going to say interface product info. It has to be product info extends product. There we go. And the interface extends the class product info. I have not specified in the challenge that there has to be a property of price. Interface extends the class that includes a price property of a type number. Cool. So let's just add that property price of type and remove that of type number. So everything is cool so far. Now what we need to do is we need to create an object from the interface, and then we need to log that. So I'm going to say const product. This is going to be type annotated to product info. Product info. And then what are we going to have? We are going to have name, which is going to be of type string. So I'm going to say TS bootcamp, whatever. And then holiday sales, holiday sales, which is going to return true for us. Very good so far. And I need to probably specify holiday sales method that returns true. Cool. I need to specify that. I don't know why I missed that, but that is actually the actual challenge. And then since we have type annotated to interface, we need to provide the price as well. Very good. Everything is okay. There are no errors. Let's log the product object. And that is our challenge. See you in the next one. Welcome to challenge number 14. The statement reads, what will the course variable log? Let's go ahead and let's take a look at our challenge first. We have an interface called product that has only one property of name. Then we have a class TSCourse that implements that interface. So when a class implements the interface, it must have all the properties. So we have a name with the type of string, and then we have a public property of name with the type of string. And we can see that this class correctly implements the interface of product. Then we have a new object which has been created from the class, and since there is only just one name, we pass in the name there. And then if we take a look at the course object, the only thing that we're going to see is going to be an object for which we are going to have TS Bootcamp as the value and name as the key, since that is the shape of the object that we have specified using the interface. So I'm going to go ahead and I'm going to save that. There we go. That is it for this challenge. See you in the next one. Hi and welcome to challenge number 15. The challenge statement reads, what will the course variable log? And this is the same challenge as we had earlier for challenge number 14. The only difference is that now we are talking about a type alias and a class implementing a type alias. As we saw in our previous challenge, a class can correctly or basically a class has the ability to implement an interface, and the same goes for a type. So the class has any class has an ability to implement a type as long as it implements it correctly. So there is not going to be any kind of type error. So a class can implement an interface, and it can implement a type as well. So when it can implement a type, when we console log this object, we should only see the same result as the previous challenge. Let's go ahead and let's console log it, and there we go. That is it for this challenge. See you in the next one. Hi and welcome to challenge number 16. We have the same challenge, and the challenge statement is the same as well. What will the course variable log? Let's take a look at the challenge very quickly. We have an interface of product with a name of type string, and within we have a class which I've commented out for good reason. that implements the product. Now, when a class implements any interface, it has to be compatible with that interface. But within this class, we can see that the name property has a type of number. So as soon as I comment this one in, we're going to see an error that says it incorrectly implements the interface. Why? Because types of property name are incompatible. Type number is not assignable to type string. And even if I take a look at the object, we're going to see that argument of type string, which we have passed in right here, is not assignable to parameter of type number. So it's talking about this argument of type string and this parameter of type number. So the result is going to be a type error of like several errors. Basically, type string is not assignable to type number. That is it for the challenges solution. See you in the next one.